Howdy, howdy, everybody. When will then be now indeed? What the hell am I looking at? When does this happen in a movie? Now. You're looking at now, sir. Everything that happens now is happening now. What happened to then? We passed it. When? Just now. We're in now. Go back to then. When? Now. Now? Now. I can't. Why? We missed it. When? Just now. When will then be now? Soon. It's such a good bit. Sorry. It is one of the movies of all time. All right, well, you know what today is. Today is Ask a Physicist, so let's answer some questions. What keyboard do you use? I use a Logitech G910. I love the Logitech products. Today is brought to you, today's live stream is brought to you by Logitech. No, I'm kidding. Of course not. Although, Logitech, if you're listening. If I win versus physics, does that mean miracles are real? Yes. Oh, I have to join. No, I guess I don't have to do that yet. Is logic the law of the infinite universe? I don't know what that question means. What are your views on pilot wave theory? I don't take it too seriously, but some people do, which I think is worthwhile. What causes Hawking radiation? So there's kind of the traditional story that so you accept guest requests? Not yet, but I will in about an hour and a half. Do they call you Dr. Blitz because you were fast enough to measure light speed? True, yeah. Can we get another KSB stream again? That was fun. Yeah, so I'm not saying it's permanently cancelled, it's just Saturdays have been really busy lately. Is there a smallest distance you could travel, like in Zeno's paradox? Does it reach the limit? We don't know. This is something that's currently unknown. Somebody's saying very lag. Am I lagging? I don't think I'm lagging. I'm just a little bit behind. What is the best argument against a flat earth believer, which even a flat earth believer could understand? Just ask them to explain why it is that at sunsets, the bottoms of the clouds are lit up, but the tops of the clouds aren't. Because on a flat earth, the sun is supposed to be above the clouds, so it can never be the case that the bottom of the clouds are brighter than the top of the clouds. You have a job, you're always on here. This is part of my job. Can you explain the Planck length? Why is that specifically the smallest length? It's not small. Why not smaller? It's not specifically the smallest length. It's just the scale at which we expect quantum gravitational effects to take place. Do photons have mass? No. Is there really like significant lag? Okay. Hope. Yeah. It says the vertical stream is a little bit skippy. Sorry about that. All right, I'm gonna jump down to the bottom so then I don't keep falling behind. Oh, title says creationism versus science on Twitch. Okay, yeah, good catch. You versus, I always forget to change it. Physics, and then ask. Wish I could have like presets, that'd be good. That cloud argument was terrible. Okay, well, do you have an explanation how on a flat earth the bottom of the clouds are brighter than the top of the clouds at sunset? Do you think that the variation of time is a physical reality or an illusion? I am more and more leaning towards not only time, but space being an illusion. All of it is emergent from underlying quantum phenomena. Why do you look so mad? I don't think I look mad. Can you give a quick explanation of how life began, like a cell, for example? You'd have to ask a biologist for that. Saw you read my comment and skip it. I need to know the poop. I didn't even read your question. Do you think that the variation... Oh, okay, I already answered that. Remember, by the way, there are a lot of questions. There are a lot of people asking questions. If you want to ensure that your question gets answered, you can send it over YouTube in the form of a super chat. That's guaranteed to get answered. There's, I'm trying my best to answer as many as I can, but, it's hard to hit all of them. Do photons have momentum, though? Yes, they do have momentum. What's the current leading theory on what dark matter is? It's some kind of particle. That's what probably most physicists hold to. But, there's also room for like them being tiny black holes. Have your studies pushed you more towards an agnostic view of God's existence or strict atheism? My My studies don't really inform on that. You don't miss writing papers. I'm still writing papers. I didn't stop being a scientist. I didn't stop being a physicist or a mathematician. I do this for 3-ish hours in the morning, and then I go work on research. I have like 6 ongoing projects with 3 of them are physics projects with various groups, and then 3 are math projects. When string theorists hit an obstacle in their understanding, did they stub their toe? Yes. Random question, was the cyst actually cancerous? No, it was a, what was it called? It's not a cyst. It was an abscess, it turns out. It was like an enormous abscess, which presented like a tumor. How are we as a species going to overcome the dire lack of education now that we need people to be more educated than ever? Oh, who knows, man. I'm a doomer about that. Do we live in a black hole? I don't think so. Are you familiar with Stephen Hawking's zero energy universe? How would you use it to refute Kalam's P1? Yeah, I am familiar with it. This is some, like this, you know, yes, I am familiar. I wouldn't really invoke it because that idea kind of has fallen out of favor since the 80s, since we figured out the universe is seemingly not closed. But it's an interesting idea. It's just probably too sophisticated to actually bring up in these kinds of conversations. If needed, it's always there, but it's not the kind of thing that I like to bring up because it's so counterintuitive. Does temporal inherently involve motion? No, not necessarily. What's your opinion on Kerr geometries? Do you just mean like the Kerr spacetime? Or do you mean something more broad? Because I know about the Kerr spacetime. I'm not familiar with Kerr geometries. What's your view on RS cosmology? I haven't looked too much into it. I know it's Randall-Sundrum, but I don't know much more than that. How can photons have momentum? They do. I mean, like, you can just calculate what the momentum is. If momentum is a conserved quantity, then when a charged particle in an electric field slows down, that the corresponding momentum must be conserved, and it's carried off by the electromagnetic field. Can you talk about the Amaterasu particle? Any ideas on what that could have been? I actually made a video about this a while ago. I don't remember the exact details of what I was talking about, but if you look up, I think if you look up Amaterasu and Blitz on TikTok, you'll find it. Does time really slow the faster you go, or is it just a perception of slowing? No, it actually slows. In fact, from your perception, it doesn't change at all. I thought you said this was your full-time income. Well, it depends. So, like, think of it like this. A professor, unless they have grant funding, which not all faculties at a university do, a faculty member, a professor at a university, they get paid for doing the teaching that they do. And then they're expected to do research on top of that. So you can kind of think of this as what I'm doing. So I get paid for doing the research for doing the teaching that I do. And then I get paid to do this, and then I'm kind of expected to do research on top of it. And the reason why I say I'm kind of expected is because the brand that I've built for myself is very much, hey, look, I'm an actual scientist still working. And so, like, if I stop working, then I stop being an actual scientist, right? Like, if I stop doing research, am I really still a scientist anymore? And so, like, for example, in a month, I'm going to Warsaw to go to a week-long conference on conformal geometry, gravity, and spinors. And I'm hoping that I'll present a poster. So, like, I am still working because that's part of, and I mean, perhaps the practical reason why I need to is because it's part of the brand. But the other thing is that the only reason I do this is to fund that. So make of that what you will. How's the total energy in the universe not a constant? Well, because the total energy in the universe is not well defined. The only time you'll get a well-defined total energy in a universe is if there's something called time translation invariance, meaning that if you step forward in time, the laws of physics, the underlying space-time geometry is unchanged. But when we step forward in time, the space-time geometry changes, the universe expands, so we don't have this conserved quantity called energy. Why are quantum fluctuations not the cause of the Big Bang, in your opinion? Well, it's just hard to call them fluctuations when these are the kinds of things that would give rise to time. Also, it's possible that they're the cause of the Big Bang, but not the cause of the universe. Do you think that we could ever know what's inside of an electron? It might be the case that electrons are fundamental. Why quantizing the metric if in other gauge theories the quantized object acts like a connection? People do try to quantize the connection. In fact, this is what a lot of people try to do. But there's a secondary issue, namely that in some sense, if you look at the equations of so first of all, loop quantum gravity does quantize the connection, if I remember correctly. But secondly, there's kind of a distinction between gauge theories and gravity, namely that in a gauge theory, it's the curvature 2 form that carries essentially the force fields. and it's the connection that carries the potential, and that's the thing that you quantize. However, in GR, if you write down the classical equations of motion, the force field for the gravitational field is the Christoffel symbols, or it's in the connection, not the curvature. The curvature captures tidal forces. It doesn't capture the thing that causes geodesic deviation. So that at least might give you some intuition as to why some people are kind of trying to quantize the thing one step lower, which would be the metric tensor here. Because in some sense, the derivative of the metric tensor is the connection, and we want the derivative of the quantized thing to be the force field, if that makes sense. From Keegan Pug with the $10. Thank you so much, Keegan. Good afternoon! Exclamation! Enjoying the show. Your thoughts on baby metal? I've heard not a lot of baby metal. I've heard some baby metal. I just don't love it. Like, it just doesn't do it for me. I know it should, but it doesn't. Ever used your phone and zoomed in with a polar lens? There's two suns. With a polar lens? I don't know what a polar lens is. Do you mean a polarizing lens? Because all that's going to do is it's going to show you two different polarizations. That's not two different suns. Also, protons might be fundamental and quarks could be encapsulated at point of impact. No, protons can't really be fundamental here. Fake doctor, show papers, diploma as proof. Okay. We'll get them out. Somebody always asks, so I always have them available. Here's the diploma, the PhD. It says, Doctor of Philosophy in Physics, Samuel Blitz, University of California, given at Davis, that's the university. 9th day of June in the year of 2022. Now there is somebody else on here who goes by the name of Dr. Proton, who would never do such a thing, because I'm pretty sure Dr. Proton's actually faking it. But there you go. I'm glad I could be of service. Let me just... I should really just keep that out and like frame it or something at some point, but too lazy to do so. It's just crazy that you would say fake doctor rather than just asking a question like a normal person. Okay, where are we? Let's jump down to the bottom. Yeah, my name's been public since April. So, is string theory dead only because of lack of experimental evidence, or is the math a dead end too? No, the string. I wouldn't even say the string theory is dead. String theory is not even dead. Like, I wouldn't even say it's dead, even though there's lack of experimental evidence. It's a very active field. Ever struggled with physics early on? Not really. How close or far to a gravitational constant do you think we are? We know what the gravitational constant is. It's Newton's constant. It's like 6 times 10 to the minus 11 or so. May I ask what you did your topic for your PhD? It was on conformal hypersurface geometry. What superpower would theoretically be possible in our world? I don't know if it would be. If it was a superpower, it wouldn't be. Where's your last name from? Hard to say. Somewhere in Europe, probably. Probably Austria or something. Dr. Proton actually banned me from his live stream because I was questioning his credentials. Because it seems like the only questions he can answer are questions that are like pop-sci level. There's no space curvature, Einstein theory is faked. Okay, cool. Why can't we write gravity as a Maxwell-like field theory? So you can try. For example, you could try to do something that's like not generally covariant by writing down like the connection squared or something like that. But what you'll find is that it doesn't match up with predictions. So he taught my undergrad physics class. There you go. Is there a difference within philosophy and just physics in general? What? Is entropy the cause of time? Maybe. Well, entropy might be the cause for the arrow of time. It might not be the cause of time, but it might be the cause for the arrow of time. Your name isn't public, it's Blitz. Oh, true. How would you respond to the argument that the existence of the laws of fundamental interactions, which are true despite the fact that we haven't fully articulated them, suggests a designer who can? I would say that it's kind of begging the question. Thoughts on QFT? It's hard. QFT is a very hard subject, which is why I don't do it. I tried doing the math and got negative energy for gravity, but I don't think it is the fundamental. I don't know what you're asking for. What if we have a general connection and not Levi-Civita? Does it change the argument? If you just have a general connection, there is this thing called it starts with an M. where they basically treat the connection as the dynamical variable. And they actually show that if you treat the connection as the dynamical variable, and you assume that the connection is torsion-free, you end up with the Einstein field equations. Oh, what's it called? It's like a connection-first approach to GR. Let me Google it just so I can get the name for you. What's it called? I read the paper. It was like 8 years ago that I read the paper. Palatini, that's what it is. It's not an M. It's the Palatini formulation, or the Palatini formalism. Which, you know, it might be what you're asking for, and you still end up at the same thing. Like, you have a tetrad, you have a connection, and then, you know, then you just do the variation, and you end up with GR. Now, you could do the same thing where you just take a different action. You perhaps take like a Riemann squared action or something like that. But then you wouldn't match up with predictions, right? Unfair question. What energy scale must the next generation of particle accelerators reach to discover new physics beyond the standard model? I'm not going to answer it because you know that it's impossible to know what the answer is. How do you respond to the act and potency argument? It relies on a fundamental misunderstanding of spacetime. That's how I respond. Spacetime is the field of gravity. Would that explain our difficulty finding a graviton? Not necessarily, no. Is the reason we haven't seen aliens because we are looking too far, aliens because we are looking too far back when we look in space? No, the universe is just really big. I'm a biophysics PhD student. I saw your video on lava lamps. I was wondering if you've heard of viscoelastic phase separation with temperature gradient. I'm seeing if it could be an explanation. I haven't heard of that, although it does. Okay, I may have heard of it. At least some combination of those words. The reason why the lava lamp video was fun, and a lot of people are misunderstanding what we don't understand. We know the basic gist of how it happens. We know, like, you know, hot at the bottom, expands, rises, cools, sinks. That's not the hard part. The hard part is figuring out exactly what's causing the separation of blobs, what's causing the chaos to emerge, because in the model in the experiment that they produced, it was very, very orderly. It would go up and then down and then up and then down. There were no blobs. There was no chaos anywhere. And so there's questions like, what is the dominant mechanism? There's something called Rayleigh-Taylor instability, which is suspected to be one of the major contributing factors for how, like, the blob separation happens, but, like, that's not known. And there's a whole bunch of other factors that we just don't know what the dominant or what the relevant parameters and what the relevant kind of mechanisms are that cause the behavior. And there's a lot of possibilities. Do you think space and time are emergent properties of consciousness? No. Have you ever heard of a PhD level degree in spectrophotometry? No, I haven't, but yeah, I have not. How have you not been overwhelmed by all the math required, like functional analysis, representation theory, tensor calculus, etc.? I've gotten overwhelmed by it all. So eventually, when you do research, eventually what you find is that there is like a kind of a toolbox of mathematics that you're very, very comfortable with. So tensor calculus, I can do that like the back of my hand. I have no issues with that. That's super, like, it's intuitive to me. I just treat it like arithmetic, basically. Representation theory is a little bit more complicated, and I know it a little bit less well, but I know the right places where I can refresh my memory. I know the right references that I use when I need to look up some result. And so even though I don't use representation theory as much, I do know it well enough that I can figure out what I need to figure out. I can figure out what I need to know in order to make some progress on whatever project I'm working on. And some of the more basic stuff I know how to do myself. I don't use functional analysis really at all, so I don't have to worry about that. But the point is you end up building a toolbox of techniques and of, you know, math subfields that you're very, very comfortable with. And then when you then sometimes you'll run into a problem that your techniques won't work for, and then you have to go learn it. And then either you go learn it and then you use it all the time and it becomes another part of your toolbox, or you go learn it and then you don't use it again for a while, but the next time you need to learn it, you know where to look to learn it. Why did matter survive the Big Bang if antimatter was created equally? We don't know if antimatter was created equally. That's the problem. Where does the sun go at night? It goes to the other side of the world. How is deep AI and machine learning changing physics workflow and experimentation? I'm not an experimentalist, so I can't really comment. If I moved a really long pole across the galaxy, is that faster than light data transfer? Well, you can't. You can't. So you would try to push on the pole, even if you were super strong. You would try to push on the pole, but it wouldn't move. Like, the angular speed wouldn't be consistent. It would bend. In fact, this is an interesting consequence of special relativity. In special relativity, because of the finite speed of light, the speed of sound, which controls how fast propagations travel in like objects, the speed of sound is limited by the speed of light. It can't be faster than the speed of light. And so in fact, one of the consequences of relativity is that there's no such thing as a perfectly rigid object. Have you used AI in your research at all? Yeah, I have, and a lot of people have. It's useful for finding references and sources. It's useful for kind of figuring out whether an idea is a bad idea right off the get-go, rather than wasting like 2 weeks or something like this trying to figure out if an idea is good or bad. It's good for that kind of stuff. It's so one thing that you may have noticed, especially in the mathematics community, is that LLMs are really good at finding counterexamples. And so because of that, it means that if you have some idea, maybe it works like this, you tell the LLM this and it'll be like, ah, no, it can't look like this because of this counterexample. And that's really helpful. It saves a lot of time. Latest news on the bitch fight over at Supernova Type 1A. I haven't followed up since I last made the video. Thoughts on Anthropic's recent jab on the Riemann hypothesis? I looked at, so if you want thoughts on it, go look at Alvaro Robledo Lopez. He's a number theorist and a friend of mine, and he has more informed comments on it. AI is great for research and casual use is okay as well. How companies are using it is what's bad. Yeah, that I agree with. Although casual usage, you have to make sure that your casual usage just doesn't become problematic for your like mental well-being or your mental health, because that's the kind of thing that can happen quite frequently. And it has happened. You bros doing differential equations got that much. Yeah, true. If a photon has no rest mass, how does gravity bend light around massive objects? Because gravity isn't just mass attracting mass, it's mass bending space-time itself, and then objects traveling through space-time have their trajectory affected. Do you believe the US has made alien contact? No, I don't think so. Why aren't LLMs adding anything to physics like they're doing in math? LLMs seem to be, the things that LLMs seem to be doing are improving on bounds. So these, like a lot of combinatoric things, there's just like a lot of really grindy cases that you have to work out. And so LLMs can be good at that because they basically don't get bored or tired. They also seem to be really good at finding counterexamples. So this is, if there's a conjecture, it'll either, it will say, conjecture is false because counterexample. However, physics isn't really, so the kinds of mathematics that it's been good at has been that kind of thing. As far as I know, it hasn't actually been as groundbreaking in other fields where you're trying to prove things, especially non-constructively. And physics is very much, about, trying to describe or theorize about things in a non-constructive sense, and sometimes constructively. But, the kinds of things that LLMs are good at right now, and they're going to get better, of course, those kinds of things are not so useful for physics. They are still quite useful, but not so useful that we're publishing results that just are like, here's a counterexample and we're done. You're looking good, man. You've healed up well from the surgery. Yeah, I mean, I have a big old scar, but yeah, I'm doing okay. And this is still annoying to me, but back to work, but you cooked Blitz same regular talking points that aren't true. Okay, Matthew. Well, if you ever want to debate, you can come up and we can debate. How do we know light is the fastest thing in the universe? Does its speed have any scientific significance? Well, light isn't the fastest thing. There are a bunch of things that travel as quickly as light does. Gravitational waves, for example. The point is just that there is an upper speed limit to light, or an upper speed limit to, rather, not to light, to anything, and light travels at the speed limit. Have you published any papers? Yeah, like more than a dozen. Lots. 1 sec, I have to hydrate. I haven't heard of any major breakthroughs of LLMs trying to disprove open problems in PDs. Yeah, I think that's probably, I think that's reasonable. I think that the times when you'll find major breakthroughs in LLMs, at least right now, because again, they're going to get better, the major breakthroughs are going to be like, here is a counterexample that just nobody thought of. at what velocities do you have to start thinking about relativity? It depends on how accurate you want to be, right? If you care about like if you care about like 6 decimal places, then probably 1% the speed of light. If you care about, say, 4 decimal places, then maybe 10% the speed of light. I debated you previously, but I'd like to ask you some stuff. I talked to you, Justin, and Monkey Boy. Okay, well, so I will take questions over voice chat in about an hour. Do you think that you can use math to predict the stock market? In a stochastic way, you can. In a deterministic way, no, seemingly. Thoughts on people saying that the social sciences are not science? They're mistaken. Are you a postdoc? No, I was a postdoc. I'm not anymore. Where can you read my papers? Go to my website, blitz.phd, and then go to the research section. They're all freely available. Have you seen the recent artificial diamonds being used as qubits in quantum computers? I haven't, but I don't really follow a lot of the quantum computing stuff. From Pietro B. Campos with the 10 Brazilian reals. Greetings from Brazil. Dr. Blitz, I truly appreciate your content, and since a child, I wanted to graduate physics because of creators like you. Any tips for college? People say it's hard. Thanks, Doc. And I give this advice every single time, but as far as I can tell, the way to be most successful in a physics undergrad degree is to make sure that your math skills are very strong. They are stronger than the prerequisites for any physics class that you're taking. Because the one thing that you don't want to be spending time on is learning how to do the math when you're busy trying to learn physics. The most important advice I think I can offer. Thoughts on the possibility of AI replacing jobs of higher level educators like professors? I don't know. I mean, maybe it will happen eventually. I don't know if it's going to happen next year. How do scientists calculate the speed of your slop and... I see what you did there. From Garain with the $5. Is quantum mechanics truly probabilistic, or is it just chaotic beyond our ability to measure? It seems indistinguishable from probabilistic. According to our measurements. Now, there's a question of how can you actually, like, is there a way to distinguish between the two? And that's a good question. But even if it is chaotic, what it certainly is it's certainly not chaotic dependent on local variables. Otherwise, the Bell inequality would be satisfied. Do we not have mods? We must have mods on TikTok, because there's this guy who keeps talking about slopping and glocking. How stiff is space-time? If you are talking about the stiffness with regards to gravitational waves, it's very stiff. Where is Airy's equation used? It pops up a lot in optics. Would you rather be able to make lightning strike when you prove someone wrong, or be the best physicist? That'd be so funny. I don't know. Probably being the best physicist would be more useful for humanity. What's your favorite paper that you published? I really like the quantum Riemannian geometry one. I'm really proud of that. Is theoretical physics a viable career path to pursue? Who knows what's a viable career path these days? Because with LLMs and AIs and all these things, who knows where we'll be in 10 years? Do you ever forget topics from undergrad and have to refresh your memory? Occasionally, yeah. Is he taking calls or just asking for donations? I will be taking calls in about an hour, but I'm not asking for donations, I'm just answering questions. But of course, if somebody sends a super chat, they will get priority because, you know, they're supporting me, so why wouldn't I give them priority? Am I ridiculous for thinking of the universe more as an event instead of as a distinct object? Probably both are mistaken. That's my guess. How to get more into physics? Pick up a pop science book and read it. Like, a good book, a classic book even, is A Brief History of Time by Stephen Hawking. Do you know anything about string theory? A bit, but we have a resident string theorist who hangs out. His name is Chase. Chase teaches physics as his account name on TikTok. If you want to ask about string theory, Chase is the person to ask. Some scientists say information is fundamental, not space-time. How does that work? Well, so what they're really talking about is they're talking about like entanglement. So entanglement can be described informationally, like using an information kind of like it can be described in terms of entropy and bits and so on. And so there is this view, which I'm very sympathetic to, that in some sense space-time itself emerges from entanglement, which I think is a very interesting idea, and I'm sympathetic towards it, actually. You speak German? No, I don't. So regarding my family history, we kind of suspect that I have at least one ancestor who lived in Germany in like the 1700s or something like this, and maybe their name was Blitzberg or something, and they changed it to Blitz. From Lycon with the 1,000 yen, thank you so much, Lycon. I don't fully get how time can emerge from geometry without presupposing change. Even location-based, there's still local change plus geometry transitions into time, but a transition requires time. The point is that you can have, like, I don't know how else to explain this, but the point is that you have like a thing. The thing's not changing. It's just a thing. It's just the universe. The universe is timeless. It's spaceless because time and space are within it. Now, in that timeless, spaceless universe, it's just like this thing. There's like a place. There's like a part of that timeless, spaceless universe that doesn't have time, and a part of that timeless, spaceless universe that does have time. They're separate, and they're related geometrically. So there's no change happening. It's just like it's different in different parts of the timeless, spaceless thing. There are two different parts, and they're connected. Furthermore, there are other ideas where you have that time is literally like not a thing, and there's just something called a clock field, which is just correlated with different states, and that clock field is the appearance of time. Multiple questions you won't even start to touch. I wonder why. Well, if they're questions that don't make sense or questions that are ill-posed, then I won't answer them, but I haven't seen any of your questions because there's a lot of questions. Clock field. Clock, C-L-O-C-K. Could we ever tell if the universe is discrete or continuous? Potentially. This is the kind of thing that could be measured in principle, but we would need really, really big accelerators. Do we know that the universe isn't expanding into anything? It's probably a category error to suppose that it is. The universe, almost by definition, is everything that exists. So there's not really a thing that it could be expanding into that's not part of the universe already. From Pietro Di Campos with the B Campos with the 5 Brazilian reals. Hey, Doctor, me again. What do you think causes people to ignore facts and focus on belief, like anti-vax, flat earthers, and other conspiracies? I think that humans, as much as we try to rationalize our beliefs, we are ultimately tribalistic and social, and fear of being shamed, fear of being left out, fear of being ordinary. These are all things that are very strong psychological driving factors in human psychology. And so if you have two options, like either you're a flat earther or you lose all of your flat earth friends, it's a really, really steep hill to climb to get out of that. At least that's my take. From EBGHO with the $10, have you seen the show Dark Matter? Do you think we'll discover how to jump timelines? I did see the show Dark Matter. I did like it. I thought it was well done. I thought it was like dramatic and good. Obviously it's made up, it's fiction, and so you have to grant them the conceit of the show that like you can step into like a Schrodinger box and like hop between timelines, because that's not a thing, right? It's just not a thing. If there are many worlds, then they are by definition unreachable. Did you ever know anyone that was average academically in their undergrad but a great researcher? I didn't really. So in my physics community, in my physics undergrad cohort, not a lot of people ended up going to grad school for physics, and of those who did, I wasn't really friends with them. I didn't really keep up with them, so I don't really have a experience with that, with like knowing other people. Is the Big Bang truly unique, or might it just be the origin of matter in a certain region of space? It could be the latter. If T-symmetry is broken, does that mean that there's an objective direction in time? Not necessarily. It just means that there's a difference between the two directions. But which one is correct? Explain Wick rotation? Yeah, you just let time be imaginary, and then you end up with Euclidean space. I made a video on it a long time ago. Maybe I'm overdue on refreshing it. Do you believe reality is quantized? I'm agnostic on it. I'm on the fence, but I like the idea. From Milk Enjoyer with the €2, is Jackson's electrodynamics worth the pain? I suspect not. I don't actually know if anything that I learned when I took E&M from Jackson I've ever actually used since, and most of it I've forgotten, and it was just pain. That said, if I was your E&M instructor in grad school, I would make you use Jackson's electrodynamics because I had to, and it's a rite of passage. From Pietro B. Campos with the 5 reals. I appreciate your feedback, Doctor. I have to go, but I'll be back later this stream. Bonus question. Have you played the Valve game series Portal? Opinion. I played the first game for like 10 minutes and I got bored. But I appreciate the donation. And from Cooked Up Pug with the 5 Canuck bucks. Why do photons only have horizontal and vertical polarizations, even though there's spin 1, which makes it sound like they should have 3? This is because they're massless. This is because they're massless. They can't, like, they can only have 2 degrees of freedom. That's why. Basically, you can, yeah, you can find an inconsistency if they because they're massless. Yeah, that's the easiest way to put it. There's probably a relationship there, and I could make this potentially formal, that if there was a 0 spin, then a photon would have a rest, an inertial, like a rest frame, and they don't. So that almost certainly would get you there. From Joshua Brown with the $5, can you explain how to correct someone who says that altitude is a measurement from a flat plane, meaning the Earth is flat? Yeah, just tell them that you can measure up without the Earth being flat. You can measure altitude from a hill. You can measure altitude from a slope. You measure altitude in a whole bunch of different ways. It doesn't have to be from a flat plane. And from Derek First with the $2, I'm a quietist on reality being quantized. There you go. I'm a quietist. There you go. True. Do you think humans have free will considering deterministic nature of the universe? If we do, it's only because of compatibilism. Is that true that the universe is infinite, or we just don't know where its limit is? We don't know. This is an open question, and it's a really important open question in my view, because if the universe is not infinite, then in some sense, we can understand the universe a lot more easily, because there's a lot of things that are kind of hard to make sense of if the universe is indeed infinite. But on the other hand, the universe is indeed simpler if the universe is infinite. There's fewer parameters, for example. So Occam's razor might prefer the universe being infinite. From Garain with the $5, Veritasium says C could be different in different locations and it would be impossible to measure if it were true or BS. I'd have to see the claim. I suppose it could be the case that C could be different in different places, so long as all of the other constants changed accordingly so that it looked like everything was the same. But like, if all you did was reduce the speed of light, then, you know, for example, the fine structure constant would be different in different places, which means that electron energy levels would be different, right? And so, at least that's what my intuition is telling me. I'd have to go look at the details of what he's saying. Do you think next big discoveries will be by AI? Probably not. It depends on what you consider big discoveries, I guess. Do photons released at one time still follow wave-like patterns, i.e. through double-slit experiments? Yeah, photons are waves. From Aaron Alai with the $10, is it possible that as n approaches infinity for the Merman gigahertz scenarios, that f approaches 1/2 and not 1? That measurement independence does not need to be fully relaxed and locality is preserved. I have no idea what Merman gigahertz scenarios are. Oh, you're talking about GHZ experiments. Yeah, I probably don't have an opinion on this because I haven't. Yeah, are these the? Yeah, no, I don't have an opinion on this, which I apologize for, but you know, I'm not going to know the answer to every question. Yeah, it's just not something I know about, and I don't want to go read it now because then I would just be reading stuff to answer your question when you could probably read the same. But I do appreciate the question, and you know what? Maybe I'll make a new policy. When I don't know the answer, I'll just start putting it on. Oh boy. I'll just start putting it on my to make video list. Just so then you know I'm not completely ignoring you. And then I'll read into it and I'll see if I can make a video about it. Sorry. Okay. Wrote myself a note. From Derek First with the $5. It's not different places, it's C being different in different directions. Oh, like left is 2C and right is 0C. C is the one-way speed. Oh, yes, okay, that's possible, yeah. And we would never know. From Sailors with the with the Galaxy. Thank you so much, Sailors. I do appreciate that. Which areas of math do you consider too abstract? What's the most abstract math you've encountered? Category theory is the worst. That's the most abstract. Could quantum immortality be true? I don't think so. I saw Brian Cox say, from different points of view, a person inside of a black hole is going through spaghettification and incineration simultaneously. What point of view would the incineration be seen from? Okay, so this is assuming the firewall. So there's this idea. There is this idea that one of the ways that you can resolve the black hole information paradox is that at the event horizon, there's a firewall. This idea that essentially like there's just some like extremely high energy density that would just obliterate anything that tries to pass in, and so the information kind of gets scrambled. So that's why we lose the information. And there's also this idea of black hole complementarity that, you know, depending on what reference frame you're in, you could either see the firewall or not. And that would also help resolve the black hole information paradox. And so that's the idea that that he's talking about. And so the incineration here would happen from the perspective of a distant observer. The person falling in wouldn't notice it, at least if you trust black hole complementarity. That's one idea. Now, there's also black hole complementarity ideas that don't involve firewall at all, but that must be what Brian Cox was referring to. Is it hard to keep up with new theories / discoveries? How do you do that? Well, the thing is I don't. Most new theories, most new ideas that people come up with are wrong, and most discoveries are not that important. But the big ones I'll hear about probably the same way that you will. I just look on like Reddit and, you know, various news outlets and phys.org and stuff more frequently than you do. I'm doing my master's in physics, but I have no idea what field I should go into. What should I do? I like nuclear in particular. Do nuclear physics then. Nuclear physics is a huge field. It's very, very important. Does antimatter have anti-gravity? Like, does it bend space-time away from it? No. We've actually now demonstrated that, in fact... Okay, so we at least know that antimatter responds to gravity in the usual way. This has been now experimentally demonstrated. Do we think theoretical physics will disappear after we discover quantum gravity? No. Not in the slightest. Is there a good mathematical equation for calculating human movement limit? I don't know. You'd have to ask a physiologist or something. I've heard as a joke that particles are irreps of the Poincare group, but I've also heard this statement being taken pretty seriously. Is this a real thing? Yes, it's a real thing. Do you think physical laws are discovered or emergent from deeper statistical or informational principles? I think that they're... Well, I mean, they are discovered. The question is, what's their origin? I don't know. Do you think that theoretical physics will disappear after we discover... Oh, we already answered that. From Joshua Brown with the $5. My theory is that you are an amazing person. Since this is a theory, is it wrong since most new theories that people come up with are wrong? Yes. Yes, exactly, it's wrong. I have to jump down to the bottom because I'm a bit behind, but I will try to answer your questions, as always. What is your opinion on humans getting muted in your TikTok lives? Well, if they're breaking the rules, then they'll get muted. Do you think that alien life exists? Yeah. How do particles become entangled? Like, do they become entangled through things like beta decay? Yeah. So they become entangled when the origin of those particles is some kind of interaction. So like, for example, you could have like a single photon passing through a particular kind of crystal called a nonlinear optic or nonlinear crystal, and that photon can then split into two photons, and those photons can be entangled. Alternatively, two particles can become entangled when you have a particle that's in a superposition that interacts with another particle, for example. From American Tune with the $10. Thank you so much, by the way, guys. Maybe time isn't fundamental, Page Wooters, and maybe space isn't fundamental, ADS-CFT. What do you think these ideas are pointing us towards? So I'm actually working on a video, and I might start a project in the future, but who knows? I have so much going on. But I'm actually working on a video that's kind of trying to discuss this idea of emergent space in the context of something called quantum mereology, which is a really cool idea. And I think if you combine it with Page Wooters, so you don't even need ADS-CFT, you can just start from a Hilbert. The idea is you start from a Hilbert space and a Hamiltonian, and then perhaps you pick some family of ground states of that Hamiltonian, or some family of low-lying energy states of that Hamiltonian, and then between those three states, and there's no space yet at all, between those three things, the Hilbert space, the Hamiltonian, and the family of low-energy states, you can maybe reconstruct kind of a coarse-grained space. That's a thing that people are looking into, and in fact, this is something that Sean Carroll looks into a lot. But also, there's like a pretty robust group of people that are working on this. And from Sam S with the $10, physicists outside the Manhattan Project unknowingly worked with an incomplete picture. If classified programs hold real physics advances today, could open science be in that spot now? Could we tell? The thing about the Manhattan Project is that there were so many spies in there. This was like an open secret. Now, you could say that there are classified programs holding real physics advances, but there are, so at the Manhattan Project, there were a lot of very famous physicists, right? A lot of very famous people worked there. And like, we would know if all of these famous physicists were all of a sudden not leaving their universities, right? Unless you're saying that, like, you know, the universities are in on the conspiracies, like faking their, like, maybe, but like, this is the kind of speculation that probably doesn't get us anywhere. But also the Manhattan Project was more of a, there wasn't like a lot of like, Manhattan Project was, it wasn't, I mean, it was obviously science, but it was like closer to engineering. They were like trying to figure out how to build a thing, right? But like a lot of the physics that we're trying to do today is beyond that. Can you point me towards some research that nuclear physics is going through right now? All of fusion research is nuclear physics. Do you think Eric Weinstein's geometric unity theory is legit? No, not at all. Do you think dark matter is BS? No. Do you think that as we approach the truth, physics slowly begins to resemble philosophy? No, I don't think so. It's still an empirical science. Do you believe the axiom of choice is true? It depends on what you mean by true. Is some space moving faster than other space, or can gravity be shaped into long streams? So it depends. There's not really an objective way of saying that space is moving relative to other space. I'm requesting up because I had a conversation with Soli where he claimed something about you. So people will be able to come up in about 40 minutes and ask questions. So if you want to stick around till then, I'm happy to bring people up. Itchy nose, yeah, a little bit. I don't know why. I need a thesis topic for my Masters of Science in Applied Math. Any cool ideas you're into? I just made a video about lava lamps. Go watch my video about lava lamps. I give a PhD suggestion at the end. What exactly is a singularity, and is it physically real or just the limit of our theories? So a singularity, mathematically a singularity, is a place where, at least in geometry, it is a place where a path stops. You can't continue going through a singularity. In physics, a singularity is generally when something blows up. Not like an explosion, but when like some mathematical quantity becomes infinity, and it kind of ruins the theory, it ruins the predictability of your theory. Now I suspect that these things are not real, that these are just limits of our theories, yeah. From Derek First with the $2, why do many physicists have philosophy degrees too? Not many do. Very, very few do. From the Condo in Redondo with the $20, thank you so much, the Condo in Redondo. I do appreciate that. Is super generous. If the Big Bang began with a Planck density compacted into a Planck volume, doesn't that imply a fixed calculable amount of energy, matter energy for the entire universe? The Big Bang doesn't necessarily begin with a Planck density compacted into a Planck volume, right? So you could have Planck density and have volume that's much bigger than a Planck volume, right? In fact, in loop quantum gravity, you kind of expect, or loop quantum cosmology rather, there's a kind of a bounce instead of a Big Bang. And the bounce happens at the Planck density, but the volume is macroscopic. In fact, if you take the observable universe and you compress it down to the Planck density, it's like a few millimeters across, which is very much not the Planck volume. But also, this would, like, the point is that it's only the case if the Big Bang could only be compacted into a Planck volume if it were the case that the universe were already finite, right? And it's also not the case that even if there was a finite, even if you could like well define a finite amount of energy, at that point, energy is not conserved in the universe, in an expanding universe, right? From Chase Teaches Physics with the $5, geometric unity has 14 dimensions plus Susie. Supergravity works in a maximum of 11 dimensions. There are rigorous proofs. It was dead on arrival without deep thought. Fair enough. From Danny Wood, or from Danny Woolley with the £5. Hey Blitz, you need to do more flat earth debunking videos. I've now listened to your entire catalog while doing my morning walks. Great content. I would love to. on YouTube, I would absolutely love to. But the thing is we have a dearth of, is dearth the word I'm looking for? Is the opposite of dearth? We have far too few flat earthers that are willing to talk to me anymore. So what I might have to do is I might have to somehow start visiting flat earth live streams and recording them from there and then putting them on YouTube. Like, I might have to start doing that. I might have to seek them out on Mondays. I'll have to figure out a way to do that. Which fusion stock is the closest to commercial success? Oh, I don't know. I don't even know if there's a private organization that is close. Please explain the process of entropy of a single electron in a vacuum. It's not well defined. When I try to learn subjects I'm weak at, like electromagnetism, I forget it so fast. How can I improve? You can only improve by continuing, or you can only maintain memory of it by continuing to do it. Would you say that a PhD in theoretical physics is harder than a law degree? Justify? I think it depends on the person. So my PhD was easy in the sense that I didn't feel miserable. I didn't feel like I was struggling the whole time. I mean, there were things that were challenging, but I like enjoyed the challenge. You know, it was like, I want to solve this problem kind of thing. And so it wasn't hard in that respect. When my wife went to law school, it was hard. It was very hard. So I don't know if I would say that a theoretical physics PhD is harder than a law school. Theoretical physics PhD is generally longer. And there's probably more total work that goes into it. Namely that you spend more hours on it because it is longer. But I don't know. I'm not sure I would say that one is harder than the other objectively. What math would you recommend to get into mathematical relativity? It depends on what kind. Oh, mathematical relativity. You need to learn PDEs. You need to learn hardcore PDEs really, really well. You're going to stop because you're going to lose the arguments. There's a lot of evidence that the earth is flat. No, there's not. From Garain with the $5, FDFE frequently has flirfs on to debate people with science degrees. Maybe you could collab with him to debate more flirfs. The thing is they don't come to me anymore. And my prime audience, my prime source for flat earth content is from TikTok. And the TikTok flat earthers, they just don't come to me anymore. Why do you keep mixing up Soviet and Russian? I try not to. But if I do, I apologize. How did the gravitational waves change the way physicists study cosmology? Well, it basically gave us another tool. So, you know, for the longest time, up until 2015, basically, all we had was the electromagnetic spectrum to study space, right? There was just one kind of thing that we could see, and that was electromagnetic waves. And if it doesn't make electromagnetic waves, we can't see it. But now we can study gravitational waves. We have essentially telescopes for figuring out where gravitational waves come from, how intense they are, how far away they are, these kinds of things. And so now we can start using these as gravitational wave observatories. And we can now learn about a much larger class of things because we have another probe. Is physics invented or discovered? It's definitely discovered. Why don't we build more nuclear power plants? Because it's hard. Where and how do you think the universe started? I think where is probably the wrong question, and I don't know if the universe did start at all. Thoughts on assembly theory? I don't have any thoughts on it. Can you explain why the quantum efficiency of solar panels is essentially capped at 40%? That's a material science question that I don't have a good answer for. I do know that it's like 41% or so, but I just don't have a good understanding as to why. Do you think mathematics is reality, or more accurately, just a great tool to make sure your theory isn't internally contradicting itself? I think probably the latter. What math would you recommend for gauge gravity duality and or conformal frontier? You're going to need a lot. The gauge gravity duality is probably at the forefront of the most complicated physics that we do. The only thing you might not need is like PDEs. But you'll need basically everything else. You'll need like the algebras, you'll need differential geometry, you'll need functional analysis, you'll need complex analysis, you'll need, to some extent, you probably will need some PDEs, just not super rigorous hardcore PDE stuff. You'll need topology. There's a lot. Did you know that the universe is finely tuned for feet pics? Yeah, that's true. You obliterated them with the muon experiment. I think wasn't that Quantonaut's idea? Or did I I don't think I was the first person to use that, but I was one of the first people to use that on TikTok. But did it come from Quantanaut? It may have. From C-Bar with the $5. Can you restore my youthful idealism with an inspirational quote? Do or do not. There is no try. Sorry for ill-posed, but I recall a lecture that said that probabilities in basic quantum mechanics are coordinate dependent. If true, why would Cartesian coordinates give the correct answers? Well, they're coordinate dependent in the coordinate basis, in the position basis, right? But in some other bases, they will be dependent on some other coordinates, generalized. Is the universe stuck in a black hole? I suspect not. I've heard time is a temporal dimension, but what is temporal as opposed to spatial? They just have different mathematical signatures. They behave differently in the equations that describe things passing through them. Recommended book for differential topology? I have no idea. I didn't learn differential topology out of a book. I wouldn't even say that I like know differential topology particularly well. It doesn't really show up in my work at all. Do you believe in axion theory? As in, do I think that axions exist? Maybe. Is photon really object or math? I mean, it's a discrete chunk of stuff. What conformations, new findings are you looking for? I don't know what that question means. What do you mean conformations? Is unitarity preserved in gravitational collapse? And if so, where does the information go? That is a good question. It's a good open question. Do you think the axion is a good candidate for dark matter? I know that some people are still looking at it. I'm not in that field. So like, it's not something that I pay a lot of attention to. So I don't know how like the kind of the tides of scientific opinion are shifting. Sorry if this was already asked, but what do you think about simulation hypothesis? I think we have no reason to think it's true. Will humans ever actually settle on Mars? Probably. Who knows when, though? Is it possible we experience time on a delay? I mean, we kind of definitely do, because the signals between our eyes receiving light and our brain processing that light and forming an image, for example, is non-zero, so there is a delay. Dr. Blitz, I forgot that you're a Star Trek heretic because you like Commander Sisko. Everybody likes Commander Sisko, and if you don't like Commander Sisko, you can eat my nuts. I shouldn't say that. It's very impolite. What field of physics has the highest chance to find out more about the initial state of the universe? Cosmology. Is type A theory of time compatible with Andromeda's paradox? No. Do you think it is possible for any infinite quantity to exist at all in the material sense? Any infinite quantity? It depends on what we mean by quantity. I think it's possible that the universe is actually infinitely large. Now, does that mean that there's a quantity that's infinite? If the volume of the universe is a quantity, then sure. But if you mean like some like locally measurable quantity, like the amount of charge in a place or the space-time curvature within an area, then no, I suspect the answer is no to that. Did you get a doctorate in physics? I did, yeah. Are you open to allow people to speak, or is it just chat? I will be bringing on people in about half an hour. Sorry, I'm gonna jump down to the bottom because I'm way behind. Favorite representation of time travel in fiction, whether for accuracy or entertainment? Trying to think of like what the most recent time travel that I mean, I generally like Star Trek, but that's just because I like Star Trek, and Star Trek sometimes does time travel stuff, so maybe that. How do you feel about the semantic complexity of our most accurate models of physics? Even if the standard model explained everything, it would still be incredibly unsatisfactory. I'm not so sure, because look, the standard model is SU3 cross SU2 cross U1, the standard model symmetry or gauge group, and then there's just some matter particles. There's like 18 of them, and then a Higgs boson, and that's it. And that's not so bad. Sorry, there's 12 of them, not 18. That's not so bad. 12 particles. a fairly simple Lie group, or a fairly simple gauge group. From Starglints with the $10, Magic Physics Genie appears and offers to answer one physics question. What do you ask? I ask, in exquisite detail, provide a 500 or okay, what I ask is, in 500 pages or more, in the form of a PhD dissertation, what is the correct theory of quantum gravity? That's what I would ask. And then I would just have to type really quickly. Do you think the scientists of the future will eventually topple everything we think we currently know? No, I don't think so. Members only time? No, not for another half an hour. How important is IQ for high-level physics? What is true is that there have been studies that suggest that people who have bachelors of or what is it? It's something like people who have bachelors of physics or physics students in undergrad or maybe in grad school do have an average IQ that's like 130 or something, or 125. But how representative that is of actually ability to do physics, as opposed to perhaps a selection bias that high IQ people think that they should do physics rather than having the ability to do physics, is an open question. Do you think that PDEs are the language of nature and physical phenomena? Yeah, but only insofar as PDEs describe how things are related to other things. You would recommend any intro book for gauge gravity, assuming I know the basics of relativity? Veronica Hubeni wrote a pretty good, let me pull it up, if I remember correctly. Veronica Hubeni wrote a fairly large fairly good overview. It's like 50 pages long. That goes over the ADS-CFT correspondence, which is like the quintessential gauge gravity duality. It was published 10 years ago, so it's not the most recent, but if you just look up Hubeni, Hubeny, and then the ADS-CFT correspondence on Google, you should find the archive page for it. From Akira's The Cat, why are some shorts you made not on YouTube, only on TikTok? Good question. Because YouTube doesn't let you post shorts that are longer than 3 minutes. And so sometimes my videos are longer than 3 minutes, and I can't post them on YouTube. And if I post them on Instagram, they don't get sent out to anybody except my followers already. So sometimes, if the videos are longer than 3 minutes, they just end up on TikTok. It's a good question, and I wish it wasn't that way. I wish that there could be longer shorts, but then YouTube would be eating into their own, they would kind of be eating part of their own pie if they extended shorts to be longer. May I further inquire why it is you believe there may be a few or even many things that scientists of the future will say are wrong? Few or even many things. I think you're getting it backwards. What I'm saying is that there are things that we're saying now that are probably wrong, but I don't think everything that we're saying now is wrong. Do you believe eternalism is right? Yeah, I do. How much chlorine should I put in my pool? I don't know. Who developed the string theories used for tiny atom destruction in CERN? So it's not string theory that's used at CERN. They're not even atoms. This was all of science over the course of, like, from, say, the 50s all the way up to, like, the 90s. What are your thoughts on mathematical Platonism? I don't think that it's real. So TikTok does have pros over YouTube. It does, yeah. That's the reality. You could do part 1 and part 2. That's true, I could. Maybe I'll start doing that. That's a good idea. I like short shorts, but who likes short shorts? Professor Farnsworth needs to make a shorts longer. True. YouTube shorts used to catch me in a death scroll. Fair. Yeah, that is a problem, right? Do you think that we can find a way to cool data centers in space, or is it kind of just a big tech company LARPing? I think it's probably the latter. I think it's probably just LARP. Gravity warps time. If we have enough of it, could we stop time? No, you can just slow it down asymptotically. What's your area of expertise in physics? Generally gravitational physics. Like I'm kind of branched out pretty broadly, but like my firm root is in, you know, like I don't do anything that doesn't have to do with some sort of gravity. or some sort of space-time or something. You can make a video on vector spaces and Hilbert spaces. I actually have one on Hilbert spaces already. When is the Ian Blitz mathematical Platonism formal debate? Ian is slowly making their way over to nominalism, by the way. Do you believe physics should aspire to make an ontological model? That's for philosophers. Would you mind to explain the Higgs boson particle? Yeah, so there's a Higgs field, which is a fundamental thing. It permeates all of space and time. It has something called a vacuum expectation value. And it's the Higgs field that gives particles their mass. Things move through the Higgs field, they interact with the Higgs field, and they get mass as a consequence. The Higgs boson is just what happens when you dump energy into the Higgs field and you pop a particle out of it. Can we test gravity on stars, or is the telescope the control? I don't know what you mean by test gravity on stars. What we can do is we can use a telescope to make observations that are predicted in different scenarios. Galaxies, star clusters, individual stars. And so we can use the different available stars and, you know, astrophysical objects like galaxies and nebulas and so on to test our models. And the telescope is just there to give us the data from those tests. Isn't time dilation a form of gravitational physics? It's time dilation does show up in gravitational physics, but it also shows up just in standard special relativity without gravity at all. What do you think of all of the hate that Noble Ed Witten has been receiving lately due to the general anti-science crowd attacking string theory? Oh, I think it's cringe that people are anti-string theory. How do they prove time dilation isn't simply clocks slowing down rather than physical processes slowing down? Or is it based on the premise that time literally is occupying physical processes? Well, okay, so the point is that if you take a muon, which is a fundamental particle that can decay into an electron and electron antineutrino, I think it decays into an electron and an electron antineutrino. But anyway, no, I'm sorry, it decays into an electron. Anyway, a muon is a fundamental particle that decays, and when it's moving slowly, it has a decay constant of 2.2 microseconds. However, if you make it move quickly, now it decays in a much longer amount of time. It takes a lot longer to decay. So this is these are physical processes that are slowing down. What's gravity? How's it measured? And how does it work? Where did it come from? These are a lot of questions. So gravity is gravity is a few things. There's the observed phenomenon of gravity, that things fall down and that things are in orbit, and these kinds of things. And then there's the model of gravity, which is that gravity arises from the curvature of space-time. We measure it by measuring things directly, like the curvature of space-time, which we can measure directly with things like the gravity probe B, which we've done since the early 2000s. How does it work? Well, when you have energy or momentum or stress or pressure, these things produce the curvature of space-time, and then objects moving through that curved space-time have their trajectories altered because the space-time itself is curved. And where did it come from? It seems like it's always been here. What even are virtual particles? They're made up. Hoopla. All right, I have to jump down to the bottom. Muon to electron, anti-electron, nu plus nu, muon nu. Okay, yeah, there you go. Thank you, Quantonaut. This is why you're here. So the muon has an internal clock, I imagine. What is that clock? No, it doesn't. The muon is fundamental. It's not made of anything smaller. There's no internal clock. Time just is slower for things moving quickly. I'm interested in gauge gravity. Do you recommend a math or a physics master's and or PhD? You should do physics, yeah. If you want to do gauge gravity stuff, you should do physics. Aren't muons a different kind of electron? I apologize. Yeah, they're like a fatter version of an electron, yeah. What happens when photons with sufficient energy collide at a perfect angle? So generally, photons don't interact with each other. But I mean, you can produce electrons out of them. Like you can have photon-photon scattering at very, very high energies, produce electrons. Are you married? Yeah, I'm married. Do you think space and time are fundamental or emergent properties? I'm on the fence, but I like the idea that they're emergent. What new things have we learned with the James Webb Telescope? That galaxies form in different ways than we thought they did in the early universe. Do you study philosophy? Not really. How would something fundamental decay? Doesn't decay mean they sort of turn into something else? Yeah, so it is a fundamental particle, meaning it's not made of something else. But through an interaction with other fundamental stuff, that fundamental thing can, that fundamental particle, the muon, can disappear, and in its place, new stuff exists. So is time dilation proceed through molecular decay? No, not molecular decay. Time dilation this is just an example of a kind of decay that is truly a fundamental thing. It's not just like a perception thing. It's a thing that actually happens, and the rate at which it happens depends on how fast the thing is moving. Does your wife do similar work to me? No, not at all. She's a lawyer. But then how do muons know to decay at a certain rate if they don't have some sort of clock? What determines the decay? The point is that they're moving through time more slowly. They don't know anything. They just move through time more slowly. Why do you think that most people in our field are atheist or agnostic? Because if you're going to be in this field, you're the kind of person who isn't satisfied with believing it just because. What do you think about conformal field theory? Can we detect it through the Higgs? I don't know what you mean by detect it. Our universe is not conformally invariant. Things have mass. That violates especially like neutrinos have mass, for example. The Higgs field is not a conformally invariant particle. The Higgs field is not a conformally invariant field. It has a mass itself, and it has a VEV as well. But conformal field theory is interesting and very useful. Our universe looks approximately like our universe looks like it approximately obeys conformal field theories at very, very high energies. How do you interpret negative values of Wigner function? Is it somehow negative probability, or is it something else? I haven't thought about that in so long. I don't have a good answer for you. By the way, just a quick heads up, I just need to drink some water. So just a forewarning, in about 15 minutes, I'm going to be turning the live stream into sub-only mode. Anybody can watch, everybody will be able to watch, but the only people who will be able to send questions will be TikTok superfans, YouTube members, and Twitch subscribers, all of which are $5 a month. You can get access to those things for $5 a month. But this is basically to guarantee that members have the special time, because they're helping support me, that they can get their answers they can get their questions basically guaranteed to be answered. You also get some other perks from becoming a superfan or member or subscriber. You get access to my debate notes, you get access to some emojis, you get access to a private channel on Discord. So it's a good way to support me. It's a good way to get your questions answered. I do this twice a week and answer those kinds of questions. So if you want to become a superfan or a member or a subscriber on any of these places, it's not so hard to do it, and I do appreciate it if you do. So that's in about 15 minutes. I'm going to change it to that. But that said, I will bring up anybody who wants to come up and ask a question. I will bring them up. So General Mischief, you can still come up and ask a question over voice, just you won't be able to send a chat message. So from the guy who does 6790 with the $5, do you think potential fields are real? And if so, then how do you interpret the magnetic vector potential? I'm not sure. Honestly, I'm not sure. I want to say that they probably are real, but they're not. They're real up to gauge equivalence. And no, I don't really have a good intuition for the magnetic vector potential, to be honest. And obviously, if you can't, that's totally understandable. Not everybody has $5 a month that they can spare. I totally get that. But, I have to offer some perks, and this is just one of them. We can confirm muons have no clock because that would cause radiation. True. That's true. YouTube is messing with the window size again? That's weird. My color is green. I'm cool enough to kick it with the... Yeah, exactly. Yeah, your color's green, McTime. Are you interested in tutoring a PhD or master? If so, do you have a mail I could contact? No, I don't have time for it right now. Do you have any particularly interesting philosophical beliefs? Maybe. It depends on what you think is interesting. I'm a nominalist. I'm like an extreme nominalist. Oh yeah, also, reminder, if you want to see the Unapologetic crew, myself, Justin, and Ian, in a live in-person debate, there's 3 opportunities to do so over the next few months. So in October, on October 10th, we're going to be in the Bronx, or we're going to be in New York City in the place called Bronxlandia for an in-person debate. You can get your tickets online at pang-burn.com, and you can go find our poster. Alternatively, if you are on the West Coast, you can go to LA or San Francisco sometime in the middle of November, and we'll have 2 shows there. So consider getting some tickets there. I'm supposed to chill for this because we need to get butts in seats. The Big Bang wasn't necessarily coming from a singularity because general relativity wouldn't work as smoothly on the quantum level, right? As the universe was so small once it was on that quantum scale. Yes, that's exactly it. Why did you stop making long videos? You mean like the long React videos? I stopped making those because they took up a lot of time. And you know, but I never made long form videos for YouTube that were explainers. Are traversable wormholes possible? Information between locations traveling faster than light? Well, so when you're traveling within the wormhole, you're still traveling slower than the speed of light. It's just you could have non-simply connected universes, but that's not how we determine the speed at which things move. From Balthazar with the $10, do you think any scientific theory about strings may be proven through a roundabout repeatable phenomenon that is best explained by strings and less so by other explanations? As far as I know, that's what the string theorists are really hoping for, if string theory is correct. That there will be some signal that is best explained by string theory, even though it's not direct observation of the strings. That's the idea. Is it true that Schrodinger's cat was actually made to call the Copenhagen interpretation absurd and illogical? Yeah, I think so. What did you think about the response that MRE Spoon about Flat Earth made a while back? I talked to him in the comments for a bit. He seemed more far gone than I thought he was. How do electrons know they have one EV? They don't. Electrons don't know anything. Garbage wording disclaimer. Is it the movement that causes things to decay or the substance time they're moving through that causes them to decay, or is this an incoherent question? So look, the point is that muons and all heavy fundamental particles, they have this property that they decay. And the reason they decay is not because they're moving, because you could be in their rest frame and they'll still decay. And it's not because they're moving through a substance. It's just because they exist temporally, and so they exist in time. And it turns out that one can predict how many moments of time, or how many seconds, how many fractions of a second, on average, a given thing will exist for. Now, if you're asking like what causes the thing to decay when it decays, that's probably not the kind of thing that has a cause. Do you think we'll ever see another life form in our lifetime? I hope so. Does the singularity really exist, or maybe space-time doesn't bend to such a point? I suspect singularities don't exist. Thoughts on Michio Kaku, to take seriously or whack? His old books, I think, were quite good. From the early 2000s. I don't want to say poor things about him, because he was a very, very important, very serious scientist in like the 80s and 90s. He was doing very serious scientific work. But then he wrote some books, and it seems like he's kind of become like a string theory propagandist, and like he says a lot of things that just are not as certain as he says them to be. So I wouldn't call him whack. He deserves more respect than that, but he is a little bit off the deep end. Sorry for repeating, but is math an acceptable major for working on quantum computing? You should probably... I feel like physics might be the thing that you want to do. Do you ever chat with MX? Yeah, I've chatted with MX. Is Avi Loeb grifting? I don't know. I don't know what's going on in his head. When he does actual science, on like actual, like the stuff that he actually does his work on, it's actually like, these are good papers. These are good papers, and he does good science. But then when it has to do with aliens, he's like, the alien bits seems a bit like a grift. What was up with that fake Harvard PhD Dr. Proton last night? Yeah, he's just faking it, right? He doesn't have a PhD from Harvard. There's no way. I wish that my software displayed when I got a subscriber or a super chat, or not a super chat, or a membership, because I don't know how to see that. So if anybody did become a member in the last 5 minutes or so because of the announcement, thank you. I must have missed it, but welcome to the cult, the lava lamp cult. Were you born an atheist? Nobody's born an atheist. Nobody's born anything. You develop positions on things. Isn't it the W boson that causes muon decay? Yeah, but like, why is the W boson emitted when it is? If you can prove what is dark matter or a string theory is true, which one would you pick? Oh, probably string theory. Observable universe is about 90 billion light years across, but only 13 billion years old. Confused. Yeah, okay, so the point is the stuff that we can observe was emitting light. The stuff that we can observe at the edge of the observable universe. The light that it emitted, when it emitted that light, was only 1 billion light years away from us when it emitted that light for the furthest stuff. And so even though it was 1 billion light years away when it emitted that stuff 12-ish billion years ago or whatever, 13 billion years ago, whenever it did, the space expanded in the interim period. And so the amount of time that the light took to get to us was longer than 1 billion years. It was 13 billion years, 13.8 billion years or so, because that's how long it's taken for the light to get to us if it's at the edge of the observable universe. But the point is that the light that we're seeing is from when it was much closer. Now that galaxy is much further away, and we're not seeing it as it is now. Now it's 90 billion light years, or now it's 46.5 billion light years away, and there's, you know, we're never going to see it as it is now. Who's a bigger LARPer, Neil deGrasse Tyson or Eric Weinstein? Definitely Eric Weinstein. Ever debate Caleb? Yep, I have. Were you born an atheist with atheist parents? Nope. Wait, who's faking a PhD? Oh my god, Ibrahim, you have to. This is crazy. There's a guy named who calls himself Dr. Proton, and he hangs out on Discord lives, kind of doing what I'm doing right now. And he just answers questions, fine. And he says that he has a PhD from Harvard and a PhD in applied physics from Harvard and an undergraduate degree in physics from Cornell, which, you know, those are big claims. Harvard's not Cornell, Harvard. These are good schools. But he answers only the most surface level questions. He says he's only ever taken one quantum mechanics class. And like, he's obviously faking it. It's so funny. You should check it out. What's the difference between the Riemann curvature tensor and the Ricci curvature tensor? The Riemann curvature tensor measures, the Ricci curvature tensor is the trace of the Riemann curvature tensor. The Ricci curvature tensor in some sense measures like, I have a video on this, but it's kind of hard to explain. It measures like growth rates of surface areas in a direction, whereas the Riemann curvature tensor really tells you how curved surfaces are. Like if you slice your space into different surfaces, the Riemann curvature tensor in some sense can capture those. The Riemann curvature tensor can tell you things about sectional curvature, if I remember correctly. So, whereas the Ricci curvature can't. The Riemann curvature the interpretation of the Riemann curvature tensor is really not great. The closest thing that you could say is it's like, in some sense, the difference, it tells you how what do I want to say? It in some sense captures how dragging a vector in a circle changes as you do that. From Just Disappointed with the $5, do reference frames disagree on mass of a radioactive body traveling near C, since it may take 2 days in its reference frame and 2 years as an observer? You mean to decay? So the decay will be observed. So no, so there will never be an invariant quantity that's disagreed upon. Now the energy of a system depends on the reference frame, but mass is an invariant quantity. And so the mass will never be observed to be different, if that helps. The invariant mass of the system, anyway. Wait, so muons decay because of a W boson? They decay because, what's the decay channel? Is it W bosons or Z bosons? I can never remember. You'd have to ask the particle physicists. But yes. From Balthazar with the $20. Thank you so much, Balthazar, for the generous and kind support. Why do all military pilots see something they can't explain and think aliens? It feels disrespectful to both astrophysicists like my aunt, who was director at SETI for decades, and hypermaneuverable aircraft engineers. Yeah, because it turns out military pilots don't have to be smart scientists. They have to be like talented pilots. They have to understand their aircraft quite well, of course. They have to have good reflexes. They have to be physically fit. They don't have to be like brilliant people. Yeah, so the guy is LARPing, exactly. What is the best indeterministic GRW interpretation? I don't know. If we somehow came to a collective conclusion about what consciousness is and AI met that bar, would that be a devastating blow to most theists that claim consciousness points to God? Yeah, probably. Although they might say, aha, well, consciousness was designed by humans. What's the use of I in physics? I remember being told imaginary numbers have applications in physics. It turns out quantum mechanics is easily represented by using imaginary units. It shows up all the time in the mathematics. So muons themselves don't have clocks, but clocks are necessary to tell us how often they decay, and when they move fast, those outside clocks slow down. When they move fast, So okay, so you can start your clock when a muon. So you're sitting in your laboratory. You have a muon beam that creates muons and then shoots them really, really fast. You start your clock when the muon is created and gets shot off, and then you stop your clock when the muon decays. Now, when that happens, you'll get a number, and you'll find that that number is longer. The amount of time that it took according to your clock is longer than the amount of time that it would take if the muon wasn't shot out as fast. Maybe that helps. What would you say we live inside? What is the current best description of our space-time prison we all live in? I would say we live inside the universe. What's exactly a boreal aurora? It's essentially lights that you see in the sky when you're looking north or when you're in the northern or southern hemisphere. But the aurora borealis is in particular the northern hemisphere one. And those lights are caused by electrons, and it's mostly electrons, combining with and smashing into atoms near the magnetic North Pole, which is caused by the solar wind. And do you think people can travel in space at Mach 25? Yep. You can travel however fast you want in space as long as you're slower than the speed of light. Is quantum physics compatible with gravity? Why or why not? I hope so. I hope it is. I was wondering why I could only see half the YouTube comments. Didn't realize there were 2 YouTube channels. Sub to both now. There you go. There's this other one. Yeah, it's the Aurora Australis. What are virtual particles? They're made up. Fictional. Do you have any papers published in the archive? I have papers published on the archive and also published in scientific journals. You can go to my website. It's just blitz.phd. Website. In the beginning, God said, let the 4-dimensional divergence of an antisymmetric second-rank tensor equal 0. And there was like, good bit, Balthazar. Good bit. Kudos to you. As a computational physicist, this question bothers me. Yes, the universe, but what is that, brother? It's space-time and all the fields glued to it. How is being near the speed of light possible if the requirement for light speed is infinite energy? Because being near the speed of light doesn't require infinite energy. It just requires finite energy. It is almost that time. Is teleportation moving faster than light? It depends on the science fiction, I guess. Can you explain what a tensor is in an intuitive way? A tensor is a thing that transforms like a tensor. I kid, but that's basically it. A tensor is some sort of, at least in physics, it's some sort of quantity that is independent of the choice of coordinates that you use to represent it. That you use to describe it. All right, so it is 10:30, which means that we are switching over to the superfan only chat. Now, keep in mind, everybody will be able to watch, but not everybody will be able to comment. Only superfans will be able to, and that is an incentive for people to support me at $5 a month. If you don't like it, well, I mean, like, you can still watch and listen. You could even come up and ask questions verbally. But this is, it's an extra incentive for people to support the live stream, to support my my academic research, to support the science communication that I do. So consider it. It's only $5 a month after all, and it does help me out a lot more than it hurts you, I think. But I just have to finish setting things up, and then we will be good to go. And I'll start taking guests as well over voice chat. So anybody can come up and ask questions, even if they are not members or subscribers or whatever. Even if they are not members or subscribers, you can still come up and ask those questions as either on TikTok or in the Discord voice chat. Let me display the Discord URL so that people can come up if they have questions. Okay, should be good to go. Okay. Wait a minute. There we go. Okay. Let me make sure that I'm not... Okay, so I'll start with the first question that started at 10:30. Okay, so we have expansion of space increases wavelength of light. Why doesn't it also increase the amplitude? Amplitude is in some sense related to the number of photons, and the number of photons doesn't change. Why can't we make everything if anything is made of atoms? Because it turns out arranging them is the hard part. What's your favorite moon? I like our moon. How does the relativity of simultaneity... How does simultaneity of relativity... No, you mean relativity of simultaneity disprove a theory of time. Relativity of simultaneity basically says that there are... Depending on your reference frame, you have a different now than I do. Depending on like how fast you're moving, for example. And so if your now is real and my now is real, but our nows disagree, then that means that my now could be in your future or vice versa. I read in a book a long time ago that if we observe a quantum phenomenon, it will change its behavior and obey the classical physical laws. But how are we using quantum in computers and phones? So as far as I know, it's not really used in phones. There are quantum computers. Those quantum computers take advantage of the fact that you can keep them in their strangely behaving quantum state, and you can use those strangely behaving quantum states to make computations that are otherwise very, very slow or very, very hard on classical computers. Are protons fundamental? No. No, they're composite. Is there an unsolved physics problem that interests you? Yeah, quantum gravity. What's the Casimir effect? The Casimir effect is this effect where if you take two plates and you put them really, really close together, there's a force that tries to pull them together. If gravity is seen as curvature and built into spacetime, could the equations work for gravity? Could the equations work if gravity were to be seen as a field fluctuating inside spacetime rather than be woven into the spacetime curvature? No, it doesn't really work. You can't have a background spacetime because that doesn't take into account the topology. From Pensive with the $20 with a donation to the lava lamp. Thank you so much, Pensive. Always good to see you. Favorite anime? I don't know. I really like Dr. Stone, though. Other than maths, is visualization the most important thing after that, or any other thing? Physical intuition is probably the most important thing. What part of the universe's behavior do you think is not captured by our current mathematical frameworks, and why? Whatever's going on at the center of black holes. Can you explain spin in quantum mechanics? Yeah. So you know how particles can have charges, right? Like an electron has a positive charge. And there's not like a reason why it has that. It's not like there's like charge bits smeared over it or something. It's just a thing that has charge. Particles can also have angular momentum. That's just a feature of the reality that we live in. You know, there's a Poincare, these are irreducible representations of the Poincare group, blah, 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 blah. But the point is a particle is a kind of thing that can have charge, can have spin, and it could have mass. Kind of stupid question that I'm having a problem formulating. Is it possible that integration differentiation that we do in math is wrong? No, because we can prove that they're right. That's all business of mathematics. But there are different kinds of integration. There's Riemann integration, there's Lebesgue integration, there's other more sophisticated versions. Do you think God is a possibility? A logical possibility? Perhaps. It depends on what you mean by God. Do you think it is okay to study mostly math in a physics master's degree? It would be my second master's after theoretical chemistry following my teacher's advice. If you're doing a physics master's degree, if you want to pass, then you have to know the physics. So you'll need to take at least enough physics classes to know the physics to pass your exam. But then take as much math as you want. Sour cherry balls are delicious. I just needed someone to know that. Well, I appreciate you telling me that. All right, let's bring up our first guest. Let's bring up General Mischief.
Hey, Dr. Blitz, how you doing?
Hey, how's it going?
Oh, it's going great. I was on a live, so this is kind of a meandering question. I apologize. I'll make it as brief as I can. I was on live with Sully. Sully was claiming...
I'm sorry to hear that.
No, it's okay. It's all right. I'm an amateur globe earther. My extent of physics was I ran reactors in the Navy. That's my level of physics. So I was on a live with him, and he suggested that they have never detected the motion of the Earth, and they have never detected the rotation of the Earth. And he said at the highest levels of physics, that's not true. I found an article saying that the Romy detector and very long-range baseline interferometry had detected both, basically. And then he challenged that by saying that the detector wasn't calibrated by taking it up into the atmosphere or something, I don't know. And then he said that that would basically blow up our understanding of relativity. And I could not make one sense of anything he was saying. So from my recollection, do you know what he was saying? And do you know if any of that works?
Sorry about that. My wife is going to go. She has a thing that she has to go do, and it's important, so I was just saying bye.
No, that's fine.
So can you repeat everything, the last 30 seconds?
Sure. So the BLBI and the Romy detector, those experiments, he claimed that they would blow up our understanding of relativity. Basically, like relativity, if they detected the rotation of the Earth, that would somehow like destroy relativity, because that's where he moved the goalpost. Once I said like this experiment has detected it, he then asked how the detector was calibrated, and I'm like, I don't know, I didn't have the access to go live, and then he basically said in terms it would blow up relativity for us to have detected that, and it would challenge the entire theory of relativity, and I didn't know if it was general or specific, so I figured I'd bring it to you because he said even you agreed with him on that. So
yeah,
like,
no,
right,
obviously it's fake and made up. I don't agree with him on that. So what relativity suggests is that just from existing, not by looking at stuff, but just by existing, there's like what's the good analogy here? If you had like a small box, like a closed off box that's closed off to the outside world, and you tried to do an experiment in that box, and if that box was, say, orbiting the sun, you would never be able to know if it was orbiting the sun or if it was just free floating out in space. That's one of the equivalence principle, actually, of general relativity.
Okay.
Now, so he's confusing that with the idea that one could not even detect any motion of the Earth, including rotational motion. Now, the rotational motion absolutely can be detected. This is what the Coriolis effect is. There's like so much, like this can absolutely be detected, and the reason it can be detected is because it's non-inertial. It's rotational, and rotational motion is non-inertial. It involves acceleration, and that can be distinguished from just being on an Earth that's not spinning at all. Mm-hmm. So he's just mistaken. Okay. And probably not mistaken. He's either mistaken and stupid, or he's lying to you. But yeah, I mean, like a gyroscope, a pendulum, a Compton generator, all of these things pick up on the Coriolis effect, or pick up on the rotation of the Earth in particular, and that can be easily detected and easily measured. And then you're right, the VLBI kinds of like telescopes, the one I'm thinking of is the one in California. That does have to account for the rotation of the Earth, and you can actually get more data from those because of the rotation of the Earth. And if the Earth didn't rotate, then you wouldn't be able to accumulate the data that you can.
The article I found, yeah, go ahead. Yeah, the article I found was based in Germany, and I don't know if I'm confusing. They mentioned both Romy and the VLBI. So
what's Romy? I don't know what Romy is.
Hold on. It's the Romy detector. Let me see if I can find a link. I'll read the article off. But Romy.
How do you spell Romy?
ROMY.
I have no idea what that is.
Okay, hold on. Let me find this out. A multi-component ring laser for geodesics and geophysics.
Interesting. So I've never heard about this.
Motions in seismology. It detects Earth's motion, including minute variations in rotation rate, axis wobbles, and seismic rotational waves by measuring frequency shifts between opposing laser beams.
Cool.
So it's a large triangular laser arranged in a tetrahedral structure. And this is another thing he claimed. This just prompted something else. He claimed that they were detecting the Sagnac effect, but Romy actually relies on the Sagnac effect, and I didn't know enough about the Sagnac effect to speak intelligently and to challenge that. So he tried to define the Sagnac effect. Can you tell me what that is?
Yeah, the Sagnac effect is just a phase difference that's accumulated when you have circulating light beams that are going in different directions in a non-inertial reference frame. Or actually, it doesn't even have to be non-inertial, really. It just has to be circulating light beams that are that in some sense have some sort of relative motion.
Okay, and would the Sagnac effect in a detector like this negate the detection of movement?
No, in fact, it does detect movement. That's what the Sagnac effect does. It detects movement.
Right. I understand. Okay, I'm starting to get it because he tried to. I mean, I feel like it was a little bit of word salad moving the goalpost, but I want to make sure I clarify it so I understand that.
Yeah, no, Soli is one of the more dishonest interlocutors. So it was probably intentional, to be honest.
Well, he did. Not to. You know what? Soli's not the focus here. I want to understand better. So Romy and VLBI, those things kind of like VLBI detects the motion of the Earth, and Romy would detect like motion through space.
So the VLBI, VLBI is just very long baseline interferometry, and so VLBI is not like a specific thing. There are different telescopes that use VLBI. And the point is that there's a telescope in California that uses very long baseline interferometry. I'm trying to remember what it's called. Let me just Google it. It's they actually use optical interferometry, which is really neat. Yeah, it's the Chara array. That's what it's called. So they basically take, they have 6 optical telescopes, and then they use those 6 telescopes spread out over something like 300 meters or so. And they feed, they feed the images and kind of combine them in an interference kind of way. To make higher resolution images of stars and things like this. This is how we can actually see the surface of Polaris, for example, which is really neat. But importantly, they have to take into account the rotation of the Earth in order to actually reconstruct or sensible images, right? Because the delay time changes. Like if you're like the relevant thing is that there's 2 different path lengths that are getting to the different telescopes. So the light from the star might get to one telescope in this amount of time and another telescope in this amount of time. And because they're far away, that time difference is important. And so depending on the rotation of the Earth, that time difference changes. And so they have to take that into account when they're doing the reconstruction of the data.
Okay.
That's what I thought that you were referring to. But yeah, so there's a lot of different ways that the rotation of the Earth is either measured or used in order to make observations. And they all eventually come back to the fact that in order to make sense of the world, the Earth must be large, globular, and spinning.
Sure. Yeah, and what I'm reading here, the Romy detected after 47 days, Earth's poles deviated by less than 1 arcsecond, or 4.8 times 10 to the minus 6 radians. So Romy detected essentially wobble of the movement of the pole. So that's awesome. All right. Well, then thank you for answering my question. I'll step down.
Of course. Thanks for being here. I just want to pull up the Romy detector because that's actually something that I should look into for the debate stuff. So I'll read about that later. Sorry, I'm just going to close out of some stuff, and I also need to check to make sure that I didn't get any of these them their PayPals or things like that, because if I did, then I need to acknowledge them. Okay, cool. Let's read some more questions, and then we'll bring up another guest. I want to make sure I don't miss any, so I'm going to scroll up a little bit. Okay. One I often wonder about, what's something we could have invented a few centuries earlier if we had just understood one thing about physics a little better? This is a good question. What one thing could we have invented a little bit earlier? Probably something to do with electromagnetism, and then we could have had electricity. Because like anything that we really invented after like the invention of electricity kind of requires electricity generally. Can you speak to phase space and how it helps create neutron stars? Well, phase space is not a thing that creates neutron stars. Phase space is like a mathematical tool kind of that's useful for describing systems, and it shows up all over physics, and I imagine it shows up in neutron star physics. Since you're a physicist, how often do you speak to spirits from the other side? Never. Is Globe Earther a thing? Yeah, it is. Explain quarks. You might have to explain it like I'm in 3rd grade. Quarks are just, how does Hank Green say? Quarks are a fundamental constituent of matter. So they're one of the building blocks of matter. There's quarks and there's electrons, and those make up everything that you see. And there's 6 kinds of quarks. The kinds of quarks that make up everything you see, though, are just one of the 2 kinds of quarks. You put 3 of the quarks together, you get a proton. You put a different arrangement of 3 quarks together, and you get a neutron. Who can call in and how? Anybody can, but I'm trying to go in order. You can also join through the Discord. You can join on TikTok, or you can join through the Discord link behind me. Sorry, I'm just making sure I didn't miss any questions. What's your opinion on Sabine Hoffenstatter's Hoffenstatter's content? I don't know why I can't say her name. I think that when she does physics content, like actual like explaining the physics of how something works, it's actually usually quite good. But I think that she's been audience captured by the same audience that like Eric Weinstein and Brian Keating have, which means that she is like audience captured to be cynical. Also, she has like some weird libertarian politics. Do you think the Hilbert space is physically real or just a calculational scaffold? I think that in some sense, I think it's physically real, in the sense that I think the wave function is physically real, and the wave function is just like the kind of thing that lives in a Hilbert space. Was it true that we only have a true speed of light on round trips, but not one way? Yeah. What's 0 point energy? 0 point energy, if it's a thing at all, which it's not clear it is, but if it's a thing at all, it is the energy associated with the lowest level energy that a quantum system can have. And if it's the lowest level, you can't really get more out of it. The Antikythera mechanism suggests we knew things then forgot them. The Antikythera mechanism was just clockwork. There wasn't any advanced tech in there. I mean, it was sophisticated clockwork, but it was clockwork nonetheless. Why is it automatically assumed that in a black hole the mass is concentrated to a point inside the event horizon? Couldn't the mass be spread out in a volume closed inside the black hole? So if you trust general relativity, which is a classical theory, then general relativity says that indeed they do collapse into a black hole. This is something that Roger Penrose proved in the 60s, that singularity formation is inevitable. However, we know that GR isn't going to hold up at all scales, so it might be the case that there's a small little remnant left over at the center of a black hole that's not a single point. What's the difference between renormalization and regularization? Regularization is one of the ways that you can renormalize. Dalton de Broglie-Bohm pilot wave interpretation. I don't personally buy it, but I think it's worthwhile for people to investigate. Do you believe Drake made the right decision? I have no idea what you're referring to. All right, let's bring up another guest, this time from Discord. Let's talk to Kusu. Kusu, how's it going?
Hey, how are you doing?
I'm doing all right. What questions you got for me?
Yeah, thanks for taking my question. So, my question is simply, what is your opinion on the theory of gravistars as either a replacement or a counterpart which could exist along the black hole theory?
I think it's an interesting idea. It's pretty underdeveloped, though. Like, we don't have a mechanism as to how, like, the negative or the negative pressure is actually existing, like where it comes from, why it's there. But it's a good idea. I made a video about it a while ago, and I'm very intrigued by it. The kind of thing that is exciting. Whether it's correct, you know, hard to say.
Yeah, of course. I mean, I did hear that we could analyze the frequency of colliding black holes or colliding gravistars or one of either, which could provide proof for either.
Yep.
And obviously the idea, and the idea of a condensed vacuum space with quantum energy being so condensed is really interesting. But then my follow-up to this is, do we have any credible evidence that Bose-Einstein condensates can naturally form in our universe, or is it something we can only form in a lab?
I don't know. I'm sure people have looked into this to see if they can like detect like clouds that are in like a Bose-Einstein condensate. I mean, like, there's no reason to say that they couldn't. Like, if we can make them in a lab, then like it's physically possible for them to exist. It's just whether they do exist, whether the conditions are ever satisfied anywhere. That's a different question. But yeah, I don't know.
Okay. Yeah, I don't have much more than that. Just a simple question. Thanks very much.
Okay, well, thanks for being here.
You too.
We have a few more questions, and we'll bring up another guest from TikTok. Would the laws of physics be different somewhere really far away? I hope not. Otherwise, there should be more fundamental laws of physics that describes how the laws of physics change. How do those plasma jets shoot out of black holes if light can escape black holes? Okay, so this is a good question. It's complicated. It's like really complicated, and in fact, Skylar, who's a mutual of mine, perhaps even like a loose friend, if you will, who did her PhD work on stuff very closely related to this. The idea is that rotating black holes can have kind of twisting magnetic fields around them as a result of like the plasma that surrounds them that's falling in. It induces a kind of a twisting magnetic field. And essentially, there's very complicated dynamics that are like the interplay between a dynamical magnetic field and electric field, of course, plasma physics and gravitational physics. All of these things can give some very, very complicated dynamics. One of those complicated dynamics that can arise is something called the Blanford-Znayak effect, and I made a video on it a while ago, which is kind of like this kind of like the first order approximation for how this can happen. And essentially, what happens is that you end up with, in order for charge to be conserved, basically, you end up with stuff falling in, and then charge basically coming down through a jet, sweeping along the outside of the event horizon, so it doesn't actually go in, and then feeding back in again. And so nothing's actually leaving the black hole. The black hole's kind of just pulling charge down, which ejects charge up. it's complicated, and you should go watch my video. It is on TikTok and I think also on YouTube somewhere, called Blanford-Znayak, BLANFORD dash ZNAJEK. You look that up on TikTok, you will find my video on it. It's very interesting, but it's very complicated. And from Mail, what's the leading theory among physicists for explanation of the strong CP problem? I don't know what the leading one is, because it's not my area, but I do know that one of the original proposals to solve that problem was the axion. It was, I think it's Quinn-Pacini. They said that there was the idea is that there's a Quinn-Pacini symmetry, and then an axion kind of arises as a result of that symmetry being present, or something like that. How much of what we call physics is actually a theory of detectors rather than nature? That's a philosophical question. What's the most plausible tech from Stargate? I have no idea. I never watched it. How good at Calculus 1 do you need to be for Calculus 2? Pretty good. Why does string theory require so many dimensions? Because you can just check mathematically that if there were a different number of dimensions, the entire theory collapses. All right. Let me bring up a next guest from TikTok. Let's bring up Abdullah.
Hi, Dr. Blitz.
Hi, how's it going? I'm doing okay. What questions you got for me?
Yeah, so I would like to ask you, is there any logical or technical fault with calling God time? Like the
it just seems like that's
omniscient being time.
With calling it time? Probably, yeah.
Yes,
because time isn't a thing with power. So time isn't omnipotent. So yeah, that seems like that would be a mistake.
How would you define time?
One of the 4 dimensions of space-time.
So why does it have to be finite? Why can't it have...
It doesn't have to be finite, but we're not talking about finite, we're talking about power. It just seems like a category error. Like you're trying to ascribe features of an agent or features of a thing that takes actions, features of a thing that has knowledge, to kind of like an underlying substructure that other things exist within, but the substructure doesn't do anything. It just seems like a category error.
So if for example, my literature says that God is time,
I would see that sounds mistaken.
Wrong?
Yeah, it sounds like it is. It sounds like
how would you
unless you're redefining what time is, or you're redefining what God is. This is just, it sounds like nonsense.
I see. I had a few more questions.
As long as they're about physics, that's fine.
Yes. So, for example, we know that the universe is expanding, right? If is that like a recent concept?
No, it's like 100 years old.
How recent is that?
Like 100 years old.
Okay. And if I were to show you an evidence from my literature that says that the universe is actively expanding by God himself, would that be some sort of evidence for you?
Not really. This is pretty common in a lot of ancient literature, this kind of idea. That the universe was small and born from a cosmic egg and then it grew. Like that's pretty common. In fact, you can find that in Hindu literature as well. Obviously the language is different, but the idea is the same. So no, it's not so surprising.
I see. Could you explain to me why our galaxy is so flat, but in terms of its width, it's very massive? Why is that?
So it's just a sign that our galaxy hasn't undergone so many large galactic collisions. So when you have something with angular momentum, whatever that is, if you have like a gas cloud with angular momentum, for example, what tends to be the case is that as that gas cloud gravitationally collapses, which is, how you're going to form galaxies, for example, or how you're going to form even stars, what tends to happen is that there's like a core that collapses mostly, and then there's stuff going around it. But the stuff going around it, if it's all originally going in every which way, eventually things will collide with each other until they kind of cancel out, until basically everything is moving in the same direction, and you end up with a disk shape. This is why all of the planets lie on a disk. This is why spiral galaxies are disk shaped. It's a fairly common and pretty well understood dynamical phenomenon that happens. And so the way that you can break this is by just colliding two different spiral galaxies with each other. And because the gravitational collapse has basically already happened, there's not really more gravitational collapse happening anymore, and so they kind of just become a blob because stuff doesn't bump into each other anymore.
I see. Okay, well, thank you so much, and I appreciate your responses.
Of course. Thanks for being here. Take care. We have some super chats, and we'll read some more questions. Then we'll bring up our next guest. From Garain with the $20, very generous. Thank you so much, Garain. Do gravitational waves stop when once a black hole is inside the horizon of the other, or can we still listen to them orbit beneath the new mutual horizon? If the latter, does that mean something is escaping the horizon? Okay, great question. So the idea is that you have gravitational waves that are emitted when two black holes are orbiting each other, and then the question is what happens once they've actually merged? So gravitational waves are going to be emitted whenever you have a change in the gravitational field that is a quadruple moment or higher. When your quadruple moment changes, you're going to get gravitational waves. And so once you have if you have two black holes, you can describe them by their event horizons. Their event horizons are like their boundaries, and once their event horizons overlap, they are bound to touch each other. They're bound to combine eventually. This has been proven. You can't separate them once they've touched. But the point is that even once they've touched and they're spinning around, and very, very quickly, there's still the gravitational field around them is still not is still changing. The quadruple moment is still changing because the shape of the event horizon is changing. The shape of the event horizon is determined by the gravitational field. So basically what's happening is that until the black hole rings down, meaning that it basically, so they combine, they become a thing, and then they wibble a little bit, and then they kind of like, they wibble, and then that kind of exponentially decays away. Until it's settled, until the black hole is settled, gravitational waves will continue to be emitted because that kind of like the bumpy exterior, the bumpy event horizon is still not, it still doesn't have the right symmetry to not be changing the quadruple moment of the gravitational field. And so, yes, you will still have gravitational waves, but they're not coming from inside the horizon. They're coming from the horizon itself wobbling. And from John Stephen Albert with the $10, can you explain the relationship between the electromagnetic force and the weak nuclear force? Which gauge bosons are responsible, and how do the field interactions result in nuclear decay? Right, so the electromagnetic force and the weak nuclear force used to be the same thing. And in fact, we can make them be the same thing in particle colliders by getting to sufficiently high energies. They were something called the electroweak force, right? For the electromagnetic force, we have a photon. For the weak nuclear force, we have the W and Z bosons. And the relationship is that they used to all be packaged into a total of 4 bosons that were all responsible for the electroweak force. Which was an SU2 cross U1 gauge force. Sorry. And then the photon split off after electroweak symmetry breaking, and the other particles in the other gauge bosons in the now separate weak nuclear force gained mass from the Higgs mechanism. The field interactions result in nuclear decay because the W and Z bosons can cause transmutation of particles. So you can have because the W bosons in particular, the W boson has charge. So whenever a W boson is emitted by a particle in order to conserve electric charge, the particle that emits it has to change its electric charge. So if you have an anti-muon, say anti-muon has positive charge. I suppose in principle it could give off a W plus boson, right? Because it has positive charge, it could give off a W plus boson. So that means that whatever's left behind has to be neutral. And so that would be an example of transmutation of particles. This is the kind of thing that happens in decay. And then because the W boson itself is very unstable, the W boson almost instantaneously decays into less massive stuff, again, conserving charge. Good question, though. Let me clear up all the questions in the chat, then I'll bring up another guest. What do you think the boundary lies? Where do you think the boundary lies between noise modeling and new physics? Much more luminous particle colliders. That's where I think the boundary lies. How do we know what direction to aim for Mars if both planets are moving? Math. Basically, we know how the Earth moves around the sun. We know how Mars moves around the sun. you just have to model it. And there are formulas for it. There's something called a Hohmann transfer, which is basically, it tells you the correct trajectory to kind of most efficiently get from Earth to Mars. And it basically involves kind of leaving Earth in the direction of travel and then kind of going out to Mars. And depending on how far away Mars is, depending on the orbital rates, you can compute how much further ahead or how much further behind Mars should be in its orbit compared to Earth. And that will tell you when to leave, and then you just go in the direction that Earth's going in. From Matt Lloyd with the 5 pounds. Hi, Dr. Blitz. If dark energy is pulling things apart, how is the Milky Way going to collide with Andromeda? I hope you're having a good day. It's a good question. Dark energy isn't pulling everything apart. Dark energy is extraordinarily weak. It's like so weak. So dark energy is only strong enough to pull things apart when the gravitational binding energy between two things is less than the available dark energy that's kind of trying to drive them apart. That's like the useful heuristic. Now, the gravitational binding energy between Milky Way and Andromeda is big enough that they are bound together gravitationally. There's just not enough dark energy between them to drive them apart. But on larger scales, because gravitational binding energy decreases with distance, on larger scales, there's more dark energy, there's less gravitational binding energy, and so it can drive things apart. Why don't they use mechanical means to help aid rocket launches? People are working on this. What's the most magical thing natural crystals actually do? Anything interesting? If you smack them, they release light. Sometimes. This is called the piezoelectric effect. It's very weird. Why are the inner solar system planets rocky? My understanding is because they're denser. Careful there. The flirts will be saying you just said everything is disc shaped like the Earth. True. Do you have any tips for undergrad getting involved in research as a rising freshman? As a rising freshman, no. You need to take at least one class. But after you're done with your freshman year, or perhaps after you're done with your first semester, start talking to your professors and ask if they have anything for undergrads to do. We have a few more questions, and then I'll bring up a guest. Generally in physics, does your theory have to be confirmed via experiment before it's eligible for, say, a Nobel Prize? What if the theory is very elegant, but we don't have the tech to test it? Yeah, they don't give Nobel Prizes for just an elegant theory. It has to be confirmed. Or there at least must be evidence for it. Why does a black hole wobble when colliding? It's just because, like, think of two jello blobs that you chuck at each other so that they collide at an off angle, right? So they're going to merge and they might spin a little bit, but like it's not going to be it's not just going to be like a perfect merging and then nothing. There's like a ring down that happens because there's like energy being carried away in the case of the jello via like sound. There's energy being carried away in the case of gravitational waves for the black holes. So there's a lot of dynamical things happening. So it's just not perfectly symmetric until the collision has kind of rung down, if you will. What's the most plausible next leap in technology in our lifetime? I can't predict that. Do instruments define what is observable, or do they limit what is real? I don't know. A philosophical question. All right, let's bring up another guest from TikTok. I believe Rizjo was next. And then we'll bring up McTime from Discord after that. Rizjo, how's it going?
Oh, hey, Dr. Blitz. I wasn't expecting to come up here.
Well, here you are. What questions you got for me?
Quickly. Yeah, sorry, I'm kind of simultaneously working at the same time.
Makes sense.
I guess, so just something, so somebody else brought it up earlier, and it's in regard to like the flat Earth arguments. I've been like trying to look at those like less as bad facts per se, and more as like possible failures in how physical relations are represented. And like, so I noticed like someone will extract like one commitment from a well specified model, like rotation, gravity, curvature, radiation. I've seen a lot, and then reason on that isolated piece using whatever relation is intuitive to themselves, and that may not belong to the original model. But then yeah, so my question is, like in physics, how do you distinguish legitimate controlled abstraction from a case where someone has essentially detached the variable or relation from the network that gives its physical meaning?
Well, I mean,
if that makes sense. I know it's
I think I understand what you mean. So when we're doing physics, are you asking like how do people do it, or like what's the actual procedure?
Either or, I guess. Just like I
Well,
well,
so-
I like the procedure aspect as
So
well. But
so the way that we like procedurally, what you do is like if you're trying to come up with some new theory or some new model or something, what you do is you need to figure out what your starting assumptions are, the things that you kind of accept as true. So maybe your maybe your theory is it includes it's as a background assumption it'll assume energy conservation or momentum conservation, or maybe that the universe looks the same here as there, and these kinds of things. And then you'll just start building up. And then there's something new that you're proposing, some new idea. So then you propose that, and you're like, okay, you propose all of the new stuff that's going into your theory, and then you have to do a few things. You have to check for internal consistency, or perhaps leave that to future work if it's complicated. But you check for internal consistency to make sure that one assumption of your model is not conflicting with another assumption of your model.
right.
And then then another thing that you can do is you can go start deriving either mathematically or empirically, probably not empirically, I guess you do this mathematically, or almost conceptually, I guess. What are the consequences of the thing that you're proposing? And that will have some, yeah, go ahead.
Oh no, sorry. No, I was just saying, no, I'm just loving your response so far.
So there'll be some consequences. So like, for example, if you're proposing a new theory of gravity, let's say, then anything that we would typically associate with gravity, you should go and redo a calculation using your new model and say, okay, well, if my model is correct, then this thing that we observe should behave in this way. And, either that kind of measurement's been made or it hasn't. If it hasn't been made, of course, then you can go out and do it. But if it has been made, then that is kind of now, and your model agrees with the observations, of course, then your model now includes that thing. That thing is part of your model. It is a consequence of it, and it's consistent with the real world. And so you basically just do this over and over again until you run out of things that your model implies. And that's your whole story of what your model says is true.
Okay. Which is like relative. Like that's a super strong sort of model to have. Like,
Yeah.
I mean, not relative. I'm sorry. Like, because like relative to all these things, that kind of like
What things?
you have a pretty strong, like, just like anything that kind of just the whole process of like what it is that you just explained in like the procedure of all of that. Because if like you start with something and then it's like, oh, okay, this doesn't pan out, you're not going to have like a super strong.
Oh yeah, sure.
Yeah.
Yeah.
Have you seen cases where a student keeps the right physical like objects of something, but like reconnects them with the wrong relation?
Yeah. This is actually really common.
Yeah.
So what'll happen is someone will have what would be a good example? Yeah, okay. So one example would be like, okay, so say you have an electric charge, and this is the kind of thing that pops up all the time, by the way, in like an electromagnetism course. So say you have an electric charge. One of the things you learn in an electromagnetism course is how to figure out what the electric field is around that electric charge. Really basic, it's Coulomb's law, whatever. And so then people will take that and be like, the electric field around some charge is given by this formula. And then we could use that to make predictions and describe behaviors. But if I then say, okay, now instead of a single electric charge, you take like a line made of electric charge, or just like an array of electric charge arranged in a line, and then I ask what's the electric field for that configuration of electric charge, if they failed to internalize what the original thing was, they might just say, okay, well, whatever the electric charge is, the total electric charges for that line, I just plug that into the formula for the point charge and I'm done. And that'd be incorrect, because you are making assumptions that aren't actually built in, or you are kind of using an intuition that the electric charge or the electric field is just given by this formula, which is false, right? You're using one aspect of it in an incorrect way to make conclusions about some other thing.
Right.
So it does happen all the time. Yeah.
Yeah, no, and I noticed that like it happens a lot. Like people use these sort of concepts, but then like they don't really actually understand like relative. Like these aren't independent like little concepts. Like they exist like per
Yeah,
and then just,
they come in packs.
yes, packs, and like you can't just fragment one
Right.
and then just kind of go like, okay, so because what happens is you just continuously continue negating the model. Like it almost seems like they have like their own theory or model, but which they don't. They're just
So what happens with flat earthers quite frequently is that they will hear some fact about what's true supposedly about, you know, gravity or, you know, pressure, whatever it is.
right.
They'll hear some fact. And the fact might be something like, you know, pressure requires a container. And they hear that fact. Say that's a fact. Maybe they hear that in like, you know, from some
Somewhere.
it's from somewhere. Maybe it's from some YouTube video, whatever, which is like interpreted correctly as true, right?
Right.
And then they say, well, what that means is that you have to have a solid plastic or glass or metal thing in order to have pressure at all. Because they interpret what they mean by what they interpret a container to be is like this thing that they have intuition about, which is like a box.
Mm.
That's not what the container is being referred to when we say that you need a container in order to have pressure. What's really being referred to there is you need some sort of forces that are present that
right.
that prevent free expansion and that force, you know, interactions. I mean, even then that's not quite true. But like, if we're just talking about like static pressure, of course, then that's what we mean. But they'll take it to mean, oh well, you know, pressure requires a container, and you can't have a container unless the Earth is flat. So that is exactly what they're doing. Yeah.
Yeah. So like, would you say? Sorry, I don't mean to hold you because I know other people have questions. But like, say somebody takes, and this is an example that I've seen, is like Earth is curved, and then concludes, therefore, an aircraft flying level has to continuously, like, there has to continuously go downward, and so like, that's what you say. So that is that actually a consequence of the curved Earth model? Because like,
yeah, so
it's
a concept. So it's and this is actually it's an almost a different thing. It's very closely related though. It's where they take two different separate, like conceptually separate ideas, and then they try to mash them together and then don't understand how they fit together.
Right.
So they're talking about, on the one hand, they're talking about, you know, the Earth is curved. So you could imagine that if something was going around it and trying to maintain like level orientation with it, that it would have to change its orientation. That's true.
Right. Yeah,
and then they're also saying that planes can only fly in the direction that they also have like this other conceptual model that planes fly in the direction that they're pointing in.
One direction. Yeah.
Yeah, that they just go in the direction, and that you have to actively, and so their first intuition about a globe is correct, and then they have this other intuition based off of, I have no idea what it's based off of really, but they have this idea that like you have to actively adjust the angle of an aircraft in order to keep yourself level if the surface below you is curving. And that's the mistake, right? Because the point is that aircraft, like aerodynamics is complicated, but more to the point, aircraft are designed so that if their altitude gets too high, they will automatically dip down, and if their altitude gets too low, they will automatically rise up. This is called adjusting your trim to maintain an altitude. And so the point is that this is like a misunderstanding of what airplanes can do, and then applying that misunderstanding to a globe Earth to come to an incorrect conclusion.
So you've explained that really well. And like, so they extract curvature while failing as well to preserve other relations, like just even knowing the plane and then like altitude and all those things. Okay, cool. Okay. My last thing was just like a comment on somebody had said something about if we knew this sooner, like what would have changed.
Oh, the invention, yeah.
Yeah, I loved your magnetism answer to that, because that's something that like immediately I was like, electromagnetism, because I actually, Hans Ørsted, I've retrieved one of his books 10 years prior to his discovery in like 1824, so like 1809. So it's like I can't read it necessarily because it's Dutch, but it's definitely super cool. Interesting. So I loved that you brought that up. But that's all I got. Thank you so much. You've clarified a lot.
Of course. Thanks for being here.
Okay. Thank you. Bye.
All right. Let's read some more questions, and then we'll bring up another guest. We have Mick Time up next. So from Scribble Scrabble with the 3141 Canuck Bucks, thank you so much. Super generous, thank you. Mayday, I'm stranded in a distant galaxy using a phased tachyon beam through a micro wormhole to send the super chat to Dr. Blitz. You're my only hope, send rescue. PS, love the channel. So the unfortunate thing is that this message was sent in a million years. We won't be able to help Scribble Scrabble for a million years. All right, let me read some more read some more questions, and we'll bring up our next guest. If the universe has no designer, what explains the existence and stability of physical laws? I think that regardless of whether there's a designer, we still need an explanation for that, or perhaps it's not the kind of thing that needs to be explained. From Pappy, why was Riemann's work important to Einstein's work? So Riemann basically invented Riemannian geometry, hence why it's named after him. And Einstein used mathematical objects in Riemannian geometry to describe spacetime. So without Riemann's work, there would have never been the mathematical tools to actually build the famous Einstein field equations. Hold on, I have to wish my wife I have to wish her nice words. Okay. Blurfs heard a fact, misinterpret the fact, and then use their misunderstanding as proof. They sometimes just lie about their interpretation, deliberately misstating it. That's true too. I've read that the universe most likely is infinite, so does this mean that at the instant of the Big Bang, the universe had no size, and then an instant of time later, its size became infinite? Well, no. So the Big Bang probably never had no size. That would require a singularity, and probably a singularity doesn't exist. But what it does mean is that at all moments of time that the universe has existed in, the size was infinite, if the universe actually is infinite. If the sun is 74% hydrogen, then are all the planets' orbits in our solar system mainly due to hydrogen? All the planets in our solar system? No, not necessarily. The sun is mostly hydrogen. I'm actually curious what the thing is the sun makes up the vast majority of the mass in the solar system anyway. So if the sun is 74% hydrogen, then the solar system is 74% hydrogen. If the POV of all matter is the center of the universe, what would matter on the edges of the matter field theoretically see in the direction of the void? There isn't a void. There's just more stuff. There's no void anywhere. Maybe Scribble Scrabble will be waiting in a deep gravity well to slow the time. I hope so. Would time exist without matter, or does matter only slow time? Time could exist without matter. I don't see why it wouldn't. From Garain with the $2, flat earthers, down here isn't parallel to down over there. Exactly. All right, let's bring up McTime. McTime has been waiting quite patiently for quite a while. McTime, how's it going?
Hello, hold on, Miss Dr. Blitz. Turn you down on the other device. All right.
Okay.
First of all, I would like to tell you that I'm an octagon earther, and the world is like a UFC. But I got basically two questions. One about neutron stars and space maps, and I was just wondering, how do they still think that's a good way to do space, like a space map with the neutron stars? Because wouldn't you, if you come from a different perspective, wouldn't it flash a certain different way?
Well, yeah, but you can always adjust your reference frame. The point is that okay, so like, look, if I give you a map with a whole bunch of landmarks on it, but I don't tell you where anything else is, and you're located somewhere. So if I tell you I am located 8 miles from this thing and 36 miles from that thing and 2 miles from that thing, I don't even tell you any directions. What that means is that even if I have no idea where you are, if you just give me enough data points of your distance to various things, I can figure out exactly where you are.
Okay.
It's just the math is annoying, but it's doable. And so that's the idea. All you have to do is provide distances to enough things, and you will be able to isolate where your location is.
Okay, that makes sense now. Cause I ever since I heard about that pulsar star map they put on Voyager, I was like, well, if the aliens coming from another perspective, I don't know, that shit seemed like that would make no sense to them. But it makes sense now. My second question is, you already answered partial of it when I was asked you about in the chat earlier when I asked you about Stephen Hawking zero energy. But the reason why I had asked you that was because I've been lately debating AI because I don't have nobody else to really debate or anything like that, and trying to use somebody you may have heard of the say like they can nothing can exist, so they always have to be something as a argument for P1 to the Kalam. And the AI told me that is basically incredulity, and it recommended me to the Stephen Hawking zero sum universe. I'm probably saying the name wrong. Zero sum universe theory. So, want to know your thoughts about that. And I got another question, another debate tactic on knowledge, but we want to know your thoughts about the first question.
I think that I don't think it's called like zero sum universe. What I have heard is so there's something called the Hartle-Hawking state, or the no boundary proposal, which is something that Stephen Hawking and James Hartle came up with, in the 80s. And the basic idea is that there might be a first moment of time, but that first moment of time isn't in some sense caused by something. It's kind of just geometrically linked to a purely spatial thing. And if the purely spatial thing wouldn't have a beginning here, it would be purely spatial. There's no time that's flowing in it. There's not a first moment of time. There's no time at all. And it's just like a bunch of places. And so in that case, the first premise of the Kalam, everything that begins to exist has a cause. Well, if we understand beginning to exist as there being a first moment of time, and if we understand a cause as in some sort of temporal causative explanation, then in this case there just would be no cause. The cause is geometric rather than temporal. So you would have something that began to exist, in this case time, with no explanation, with no cause. And so perhaps that's what it was referring to.
Well, yeah. Well, let me run this by you real quick, and I'm gonna shoot my next question. I know you got other people, but
sure.
How it told me was that the zero sum. I know I'm saying the name wrong, but this is the best way I can remember. The zero sum universe is gravity. I think. Oh, it said think of the universe as a bank account, and gravity is the debt, and matter and energy is the money. When you add it together, you have zero, and you don't need a God to create zero. That's
not Stephen Hawking. I know what you're talking about. This is this is something that comes from the Wheeler-DeWitt equation, basically. At least that's the idea.
Okay.
And the idea is that like if the universe has net zero energy, then there's not really anything required to explain why it doesn't have to, like, how do I want to explain this? If your energy is net zero, then you don't need time to explain it at all. And so if the thing is described non-temporally, then it doesn't even have a beginning.
Okay, and the final question about the debate tactics. I've been trying to use the definition for knowledge from data information systems, which links it to prediction value. Knowledge is the use of data / information to predict the behavior of a system to a desired outcome, basically. And I try to use that to eliminate what theism call knowledge, because they can't predict God. And it just seemed like, and I just want to know what you think about it. Do you think that would be a good tactic? Is it honest? Is it fair? Or just your thoughts in general?
It could. I think that debates over what knowledge is probably end up being useless. Like nobody ever learns anything, and it's just kind of usually arguing about semantics. But like if that comes up, it could be a good way to kind of circumvent the whole conversation.
Okay, well, thank you. I don't, despite the fact that you like Cisco, you're all right with me, Dr. Blitz.
You don't like Cisco?
Well, I mean, I liked him. The one thing I didn't like about him was he was a commander for like the first 3 years of the series, and I thought he should have been the captain the whole time. You
That's not his
look
fault.
at my
What you're just telling me that you're telling me that just because a black man wasn't promoted in time, you don't like him?
Yeah, exactly. He should have been captain from the day when everybody else was captain.
It sounds like you're mad at. It sounds like you're mad at the white supremacist Starfleet institution and not at Cisco.
Yeah, basically, but it's just the whole, and the thing with Voyager, and they give the captainship to the woman for the first time, and she get lost. I didn't like that either. You know what I'm saying?
That is funny. That is extremely funny, by the way. Like I haven't made that connection, but you're absolutely right. They did do that.
Yeah. Well, I thank you, Dr. Blitz, for your time. I appreciate you answering my questions. I can only imagine answering all them questions like trying to get a glass of water from a water hose on full blast. I can
Sure.
just imagine. Thank you,
We
sir.
do our best. Thanks for being here, bud. You know, I never thought about it that way, that they did give the first female captain the role where she gets lost. That is exceptionally funny, and also it's kind of shitty, but it's really funny. The realization is really funny. But it was the 90s, I guess, so I'm starting university in a STEM field in 2 weeks. Do you have any tips, things you would recommend? It depends on the STEM field. I don't have any experience with like chemistry or bio or anything. Like if you're doing physics, make sure your math is good, but I don't know about anything else. If you put a heavy enough element in a proper reactor, you can manipulate a gravity wave. Why ignore? No, not really. Gravity is so much weaker that it is negligible. It's beyond our ability to measure those things. Are there any other fundamental field potentials apart from the Higgs field that are weirdly shaped? Do we suspect any other fields to have other local extrema? No, not that I'm aware of. If the interior of black holes is undefined or emergent, what does that imply about the completeness of physical description? I don't know. I don't think that they are undefined or emergent. I think that there just is an interior. Debate Flat Earth Dave? I'd love to. You'd have to come up onto my show, though. Does Occam's razor mean that aliens built it as the simplest solution? Depends on what the alternatives are. All right, let's bring up a next guest. I don't know who's been waiting the longest. Let's bring up Dolev, though. I remember speaking to Dolev, and I gave him some homework. Dolev, how's it going?
How are you? You remembered?
Yeah. What you got for me?
Okay, I listened to the book that you talked about. It was actually pretty mind-opening for me.
Good.
So thanks for that. I do have some questions though.
Sure, go ahead.
Okay, so I want to ask, like, what do you think about like the plan to like colonize quote unquote Mars?
I think that like it shouldn't be like our intention to try to escape the havoc that we're causing on this planet. I think that it's like worth doing. I think that humans should spread out. But I don't know if it's something that we need to do immediately.
Okay, fair. Second question. What do you think about like Europa? Like when we get the data back, what do you think will like
I'm hoping that we'll see life. But
like,
you know,
do you
it's
think
hard to
we'll
say.
Okay, that leads me to like my next kind of, it's like a added question to that. Do you think we'll ever find like intelligent life as in like similar to us, how we're like pretty high IQ?
I don't know. It's not what I suspect is actually fairly common in the universe is like primitive life. Not like birds and apes, but like bacteria. I suspect that like bacteria probably exist. Maybe not like everywhere, but they seem like they're like it's probably pretty easy for bacteria to form.
Yeah. Okay.
So I wouldn't be surprised if there were planets within 100 light years of ours that had bacteria on them. I wouldn't even be surprised if there was bacteria in our like elsewhere in our solar system.
Really?
I don't
In
know
our
how.
solar system?
Yeah, I mean, like we have evidence of bacteria on Mars, right? It's not proof, but we have
isn't that
evidence
like
of it.
ancient?
Yeah, it doesn't exist anymore. But the fact
Yeah.
that like if it's true that they did exist, you know, billions of years ago, then that just indicates that it's easy enough for bacteria to develop that it happened twice in one solar system. So I
Okay.
wouldn't be surprised if it still existed in other places that are kind of less dead, like Europa. But it's not clear to me. So there's a few steps that gets to like large animals like us that it's just not
Yeah.
clear to me how often that happens evolutionarily. So like the development of multicellularity, we know how it happens. It's just not clear that it'll always happen. And then
So
beyond that, once you have animals or once you have multicellular organisms, it's not clear to me that like anything would ever necessarily evolve intelligence, because intelligence is only one solution to various environmental problems, and it's not the only solution. It's just the one that we happen to do. So it's not clear to me that how common intelligent life is, but I wouldn't be surprised if ordinary life was actually very common.
Okay, so you think it's much like it'll be very hard to find intelligent life compared to like
Yeah,
bacteria?
I honestly wouldn't be surprised if we were the only intelligent life in the galaxy.
in the galaxy. Wow.
Which would be kind of a bummer because we're never leaving our galaxy, but I
Yeah.
wouldn't be surprised.
That's actually what I was gonna ask. Do you think there's ever gonna be like a transportation system that could ever lead us to like other galaxies in a matter of a lifetime?
I'm kind of skeptical, but maybe, you know.
Like there's like the idea, like it's mostly sci-fi, but like wormholes, warp drive.
Yeah.
Like,
Yeah,
all
I
of
mean, the
those
thing
are,
is like, it's hard to speculate on these things because, like, you know, there's so much about the world that we know now that we thought, or there's so much that we didn't know about the world 150 years ago that we know now that they couldn't even conceive of 150 years ago. And so, like, it's hard to make predictions about 30 years in the future, let alone like 1,000 years in the future, right?
Yeah.
So it's just really hard to say. Like, maybe, but, you know, whatever we do it with, it will be unlike anything that we've ever conceived of.
Yeah, because like I remember like reading something. It was like 50 or like 70 years ago about like warp drives. They said it would need like the energy of 2 universes, and then that went down a lot to like
No, that wasn't 50 years, that was 30 years ago.
Okay, yeah, I didn't remember
yeah.
like the timeline, but that's
Yeah,
like
yeah. So we've definitely improved on it, but the thing is you still need matter that has negative mass, and that still doesn't exist.
Is it that it would never is it that it's not possible for it to exist, or we just haven't found it yet?
So we don't have any way to even think of that possibly existing. Like there's nothing with like in all of our theories, there's nothing with negative mass. So like maybe our theories are wrong and there exists things with negative mass, but we don't know what it is or how it works or where it can be found or anything like that.
Okay, that's all right. I was hoping for like a more excited answer, but like
Sorry.
it's very realistic. It's very realistic.
Yeah, I know. That's my job.
I have just one more like one and a
sure.
half, basically.
Yeah, sure.
Do you like the Kardashev scale? Do you think
Yep.
we'll ever make it out of like 1 or 2?
Out of 1 is possible. Out of 2 is unlikely.
Okay. And one more about AI space, like about AI like centers in space, which is like Elon and NASA and also China's planning to do it. Do you think that'll be like because I saw a video, it was like in our night sky, if we have like 1 million plus satellites in space, that we will see more satellites than stars. Do you think that'll actually
I mean, that's that's actually true if we keep doing this. Like, this is actually a problem for astronomers because like, you know, the corporations and the government don't really care about astronomers, so they're just like, let's just pollute our night skies, which, by the way, is like really shitty just for everyday people too, because, you know, throughout all of human history we've had basically the same stars, and now they're ruining it.
So do you think, but like, what's another like way to go about it? Because the data
just
centers
don't worry
on
about
Earth,
putting that. You just don't need to build that many. Don't worry about it.
So
we
you
don't have to
put
put like we don't have to push forward as fast as like money can buy. Like, it's just like, it's not necessary. Like, AI, we already have like pretty strong like AI systems. You know, we don't have to keep building more and more data centers at all. Like you know, we could do this slowly. There's no reason that we have to like destroy our night sky. There's like, we can wait till we have more efficient ways of doing it. We can improve our algorithms rather than just dumping more data. Like, it's just not necessary, and I wish that you know, governments and corporations saw it that way.
Yeah, I feel like the only reason like they're really going this fast, and also like the moon and Mars, is because of like other countries like Russia, China, that
Well,
are
but I
like
mean,
not Russia anymore, but
I mean, like,
China.
even China isn't building data centers in the way that we are. China's models are way more efficient than ours.
How are they like? What's the difference between ours, like what we're trying to do, and them?
They just have different training methods. The Chinese models.
Okay.
So they're like slightly worse than ours, but they're like 100 times more efficient. So like,
so in due time it'll be better than
yeah, like I think theirs are like on average like 3 or 4 months behind ours, which, like, fine, but also they don't have to build a data center outside of like every single town. So you know, I don't know. I just it's because they're prioritizing like profit, and you know, they don't really care about what they're actually doing to the, you know, normal people. So
yeah. I forgot, like, I had one more question.
Yeah, sure, go ahead.
It's fast. I read about I listened to a book, The Universe by Brian Cox, and
Mhm.
it talked about, because you know how in our solar system all of our rocky planets are in the inner solar system and then the gassy ones are in the outer. I
Yep.
forgot the name of the solar system, but then they found that there was a big gassy planet in the inner solar system of
Yep.
that one.
Yeah, so what we're actually finding out is that it may not be the case that rocky planets in the inner solar system and gaseous planets on the gaseous and icy planets in the outer system, it might actually be the case that that's not typical.
So we're very okay.
It's not clear. This is stuff that we're still learning, because we don't. The thing is as it currently stands, we have a really hard time seeing small rocky planets, and so it's hard to say, like, when we look out at other stars, it's hard to say where are the small rocky planets that we can learn that. Like, we're still finding them, and so maybe we just don't have enough data to actually figure it out.
Yeah, that's a lot to think about. All right, thank you so much.
Of course.
Have a great
day. You enjoyed the book. Take care.
I did. Thank you.
I don't actually remember which book it was I recommended. It may have been something deeply hidden, maybe, but it may have been A Brief History of Time. Thank you, Jam, for the $2. I do appreciate. Oh, why isn't it popping up? There we go. I do appreciate you, Jam. Let me read some more super chats, or not super chats, regular chats, and then I'll bring up another guest. If the universe began in a low entropy state, what physical principle selected that state? I don't know. I don't know if the universe did begin in a low entropy state. Rocky is real. Rocky is real. True. Flamingos on Venus wouldn't surprise me, actually. Really? 1 times 1 equals what? What do you think of Terrence Howard? 1 times 1 is 1, obviously, and Terrence Howard is a nut job. What part of the universe don't we understand? The interiors of black holes, for example. I'm low-key resentful of how much sci-fi convinced me we'd have people leaving the solar system with my lifetime. Yeah. I feel sad whenever I hear young people talk about Elon as though he's some kind of visionary. Me too. I can see like 3 stars in Dallas. So I will be right back. I'll be right back. Don't go anywhere. Dallas's light pollution is worse than what I have in up in Phoenix. However, even with the worst light pollution, you could actually see some really cool things with a telescope. Now, I am shilling for this telescope. This telescope, it's a small, smart telescope. It's made by Dwarf Lab. They sent me this for free. They pay me to make videos for them. We now have an ongoing relationship, so that's cool. I don't have an affiliate link anymore because, it was part of the negotiation. I negotiated away my affiliate link, but it is a really cool product, and so it turns out even with some serious light pollution, you can actually see some really neat things. In fact, let me show you an example of a really neat thing that I took. And, I'm like, they didn't ask me to show for them on this live stream. I just like the product a lot. I just like the telescope. It's really fun. So I just wanted to show you guys it. So here, this is an image. One sec. And let me put it on the other one too. This is an image stacked from several hours of exposure of the Triffin Nebula that I took in my backyard in a suburb. So the light pollution isn't great. I can't see a lot of stars with my naked eye, but with the telescope and accumulating lots and lots of data, you actually can. So yeah, I mean, like, it's really quite spectacular. Buy it or not, I don't care, because I don't get any affiliate commission, but it's a really, really cool thing. So if you're considering it, maybe this is my first telescope too, and I love the thing. And it's been raining and stormy these past few nights, so I haven't been able to put it out and take pictures, but I usually put it out every single night. So anyway. Just looking for questions. For the W and Z boson, we think that the potential looks like a parabola centered around 0. Is it possible? Okay, well, so yeah, neglecting the mass terms. The mass terms give you a potential that looks like parabola, but that's induced from the Higgs mechanism. It's not something that's built into the field itself. Hi, may I put a paper draft I'm working on for your peer review live on Zenodo and you live review it? Nope, I don't do that. Could you ever see someone entering a black hole, or will they just disappear? No, you can never see someone enter a black hole. Just double checking. I want to see an image of me using the telescope. I'm actually, I made a video a while ago that has me using the telescope in the video. Why not use words known universe? We use the words observable universe. All right, let's bring up another guest. We have a guest from Discord. We'll call them, their name is Dang Joes. Let's bring up Dang Joes. Dang Joes, how's it going?
How's it going? So I had a question continuing from the muon conversation from earlier.
Yeah.
So my understanding of relativity is that if someone is moving fast,
by the way, your mic is really quiet.
Oh, hang on a second.
If you could just talk louder, that might help.
Okay. Give me 1 second.
Okay. If I buy a telescope, I better see some galaxies. Yeah, so much better. Yeah, go ahead.
Okay. Probably the headphones. Anyway, yeah, my understanding from relativity is that like someone is moving fast relative to you. From your perspective, like their clock appears to be moving slower, right?
Yep.
And I guess my confusion initially when I said that the muon has like a internal clock is I was thinking like the reason why it decays, it takes longer time to decay on average is because like when it's moving, from my perspective, its clock's moving slower. But I guess someone was saying that like
you could think that it has an internal clock, but it doesn't actually have an internal clock.
Can you say that one more time? Sorry.
You could imagine that it has an internal clock, but it doesn't actually have an internal clock. Like,
is there like something outside of it that's like acting as a clock, or?
No, it's just a property of muons that they only last on average for 2.2 microseconds in their inertial frame. That's just like a property of muons. They have a decay constant in the same way that like a nuclear, or like a uranium nucleus has a decay constant. It only lasts on average 4.5 billion years or so. Like that's just they have a degree of stability, and you can just ask how often does it or how frequently does it decay. You have a bunch of them. Now if you're asking like why they decay when they decay, that's probably not the kind of thing that has an answer. It's like it is actually random. It's just the distribution, the distribution of the randomness has like a median, a mean.
I mean, maybe this is getting philosophical, but it feels to me like there has to be some sort of reason, because I could imagine another universe maybe with different physical constants or something where the average decay time is different. And I feel like there must be some reason why it has to be different.
So there's a formula for the average decay constant.
Okay.
You could in principle compute it if you knew all of these, if you knew the relevant laws of physics. These are, computable via like Feynman diagrams. And so like we know what affects it, but the question is when does it actually decay as opposed to when will it on average decay? That's a different question.
Okay.
And like fundamentally these are like stochastic things because we're talking about quantum mechanics.
You can't really predict it exactly.
Right.
Sorry. Yeah. Okay, so it's just.
I mean, perhaps one way that I could maybe assuage you, and this is going to be not quite right. In fact, it'll probably be quite wrong, but it might give you some intuition for the kind of thing that's happening. Mm-hmm. So the muon is a kind of particle, and it interacts with a lot of different fields. It interacts with the electromagnetic field, which is because it has charge, but it also interacts with the W and Z boson fields. These are quantum fields that exist everywhere. And because of this interaction, you can think of the muon as like kind of nudging the W and Z bosons whenever it exists.
Right.
And given a nudge, maybe you say that from its perspective, it nudges 1,000,000 times a second or something. You know, this is obviously just like for the sake of argument, right? It nudges it 1,000,000 times a second, and it's just the probability of a nudge turning into an actual W or Z boson, which would then result in a decay, is maybe has a probability of 1 in 3 million or something. And so then you would expect that like every third of a microsecond on average, you would get a decay. And so it's more that like the muon is interacting with these underlying quantum fields, and then as a result of that interaction, sometimes you get this decay. It's not as simple as that, because it's not like just a thing like nudging something. It's more complicated, and it's quantum it's quantum field theory fundamentally. But like that's the kind of interaction that's happening, and the probability of that interaction happening is governed by things like interaction strengths, like how strongly the muon is coupled to the W boson and so on.
Right. Okay, that actually helps, even though apparently it might be wrong, but because
it's very surface level. It's not like wrong, but the point is that you don't like need a clock that knows something about time. You just have to know that like there are rates involved in quantum mechanics, and those rates can control things.
Right, that was basically my question. It's like I wasn't necessarily trying to say that it must have some sort of clock. I just felt like there had to be something with some sort of rate or something that has a reason why it would be different, like in a different reference, That makes sense. If I may ask one more question.
Sure.
This one might be slightly philosophical, and probably won't take very long, but it's about the Andromeda paradox. It's something that bothers me. Like, I understand that not all philosophers agree that it somehow proves the B theory of time, because to me, like, even in principle, like in relativity, right, it's not actually possible to test it to be correct, because if Andromeda is millions of light years away, we can say that
you can test relativity of simultaneity. You absolutely can.
No, I mean, like, I agree with that. That's not what I mean. What I mean, like, is like, when they say like if you were to bike towards an alien at 30 miles an hour, that is going to be however many days in the future or something like that. In Andromeda, I'm saying that can't really be tested, right? Because
I mean, it can be.
Have to wait like millions of years. Like,
in that case, it's not practical. But the point is we can run basically identical tests on Earth with higher speeds, so that you don't need to be as far away.
Right.
And those things can absolutely be tested. Like, you can absolutely detect you can absolutely detect how your reference frame affects simultaneity of events.
But that but aren't those events still within the light cone? I guess I'm saying that like
no, the events are spatially separated. Outside. No. So the idea is that like you can have two events that are simultaneous. Like imagine like a light bulb flashing. Like you have two light bulbs that are separated by like 30 feet. They flash simultaneously in one frame. In another reference frame, they will flash at different times, meaning that you'll receive the signal at different times.
Oh yeah, you're right. That makes sense. Yeah, that wouldn't be in the same light cone. True. Okay. All right. Thank you.
Of course. Thanks for being here. All right, let's answer some more questions, and then we will. We have time for probably one or two more guests, depending on how quick the questions are. Let me scroll up. That's how we've done it. We've done it. Indeed, we have. Indeed, we have done it. If I buy a telescope, I better see some galaxies and black holes. Okay, well, galaxies you can see. Let me show you some that are super, super neat. I just have to go find them. Yeah, here's some galaxies. This was also taken with the same telescope. That's the Andromeda galaxy and two of its satellite galaxies. So you have the big one in the middle is the Andromeda. The big blob, slightly smaller blob to the kind of at the top is M81, I want to say, or maybe M82. It's one of its satellite galaxies, and then you have the kind of bright blob down at the bottom right near the edge of the Andromeda galaxy. That's another dwarf galaxy, but it's smaller and brighter, more dense with stars. Yeah, you can definitely see these things with such a telescope. M83. Yeah, I can't remember the names of these things. We have another question. Which way to past in an infinite universe? I don't know what that question means. Time is a figment of imagination. Everything happens at once in an infinite universe. Okay, that's a cool claim. Best way to let someone know science changing is a good thing. Just ask them if they think that the development of MRIs was good for human flourishing regarding like cancer diagnosis. Does freezing a radioactive material change its decay rate at all? No. Interesting, isn't it? To get to the past, take the second left. True. Okay, let's bring up Depis? Or is this supposed to be Dennis plus C? Depis, how's it going?
It's alright. What about you?
I'm doing okay. What questions you got for me?
You know, quantum fluctuations, are they actually uncaused?
They seem to be that way.
Alright.
Anything else?
Also, I don't really know that much about like very specific things in like quantum whatever. Sorry, I can't talk. So you know quarks, can there be like different arrangements of quarks? Like,
yeah,
I don't know.
Protons and neutrons are two different arrangements of the same kinds of quarks.
And why can't there be like, what about the other ones? Because like, there's not just
those particles that you can make from arranging different quarks in different ways are just less stable, so they decay into, you know, less heavy things.
Oh, so they actually exist?
Yeah, quarks exist. Yeah, and so do other arrangements of quarks. So like, there are kaons and pions and hyperons and omega baryons, and there's like a whole slew of like hundreds probably of different different arrangements of quarks that you can make, and they all have different lifetimes and they decay in certain amounts of time and so on.
That's cool.
Yeah.
Can they form like atoms in some sense?
So probably not, because they decay too quickly.
How quickly?
Depends on the these are called baryons and mesons, or well, hadrons and mesons, I guess. But it just depends on the kind, but it can be on the order of like 10 to the minus 20 seconds.
All right. Also, another question is,
Yep.
What about, you know, infinite regress? How is that like possible? Because every time someone asks me that, I just can't answer it.
Well, it's one of those things where like mathematically it makes perfect sense. From a physics perspective, it makes perfect sense. Like we have no problem describing things that have an eternal past. And so, you know, unless there's some reason to think it's impossible, I think that we kind of go with what physics and mathematics say is fine. And, you know, as far as I'm concerned, there's not really any arguments that rule it out, so I don't see why we should think it's impossible.
I mean, isn't like the typical argument, what is it?
That you can't get to today from an infinite past, but it just assumes that there's a beginning where you're starting from. If the past is infinite, then there's no beginning, so there's no issue with getting to today from an infinite past, because there is no beginning an infinitely long time ago. That's the typical argument, and it's just confusion about what it means for there to be an infinite past.
Yeah, if the B theory of time is true, does that mean that like I can just say the universe exists?
Yeah. If the B theory of time is true, then like any criticism of the infinite past, of like an eternal past, is like completely falling flat on its face. But even under the A theory, there's not really any arguments against it that are like reasonable or effective.
All right. What about the C theory? I've heard.
I don't know a lot about it.
I don't know what it is.
I've heard about it. I don't know a lot about it, so I can't comment.
All right. I think that's it.
Okay. Thanks for being here. All right. I don't see. Oh, do you share the view that all matter in the universe is trending towards iron? That it's iron or nickel. Both of them they're basically equally stable. That does seem to be the case, as long as, you know, there's a mechanism by which it can get there. Blitz is getting cooked. I am. Okay. Let's bring up Exotic Goku. Exotic Goku, how's it going?
Hello.
Howdy. What questions you got for me?
Oh my God, I'm sorry. Just real quick, I just noticed I was going on your channel, and your thumbnail, like from 2 years ago, from like trolling flat earthers or whatever, is crazy, bro. Like I did not know that you could look like that. You look
Yeah,
like
I just have to put on a beanie, take off my glasses, and then look like a stoner. It's so easy.
I know it's wild, and you actually mastered the flat earther look very well. Like
Yeah, of
half of them
course.
do look like that.
It's the experience that I have.
It's crazy. Also, I
The
just wanted to
beanie
say
makes
it's a
the
huge
man.
honor to. Yeah, I just wanted to say it's a huge honor to talk to you. Like, being able to communicate with a theoretical physicist is wild. So
Well, I appreciate that, but don't get my ego too big, otherwise I'll
I
start-
know it's just like, bro.
Yeah.
Like, I used to try to like email Michio Kaku when I was like 11. And, like,
Yeah, but I'm
ask
not
him,
Michio
like,
Kaku, I'm just a guy.
I know, yeah, but
That's
it's
the thing to
crazy
keep
that
in
you're.
mind.
Yeah, you are a theoretical physicist, though, and that is
True.
no laughing matter. So,
Fair
I
enough.
very much respect that. But so a couple questions. So I've heard like that in this claim of if the universe were truly infinite in size, then you could have like a recursion of the exact same configurations of matter here in this local space, like somewhere else, because of, like
Yep.
how entropy works, basically.
Yep.
And so, like the idea that there could literally be like an exact copy of you, some like given distance away, because we would expect the matter to reoccur and configure in that same way.
Yep. Disturbing,
And so,
huh?
is that's yeah? So like, and that's like an actual.
Yeah,
I don't know.
that's
Like,
just real.
yeah, that's pretty wild. And that's like that's not the multiverse exactly, right? That's like
No, it's just one universe.
Yeah.
It's just really big.
Yeah,
I mean, like,
that is
in
pretty
fact,
wild.
if the universe is finite but big enough, then you would also expect to see another copy of you, right?
Yeah, I remember. I think I can't remember if it was 60 Symbols. I think I watched, but like some physicists that they featured on there like showed the calculation for how you can at least calculate like a maximum distance, like where beyond that you would definitely expect
Right.
a recursion like that. And yeah, what was the other question? Okay, well, all right. This one I had, it's so I am a Christian now, but when I used to be an atheist, and when I was an atheist, and I would debate people on the existence of the universe and whether like it had a beginning or not. And I know that you take the view that there, it's reasonable to think that the universe existed for infinitely back in the past. That
Yep.
there is no beginning. And I actually really appreciate the herding Hawking model that you
Hartle.
feature a lot.
Hartle. Yes, Hartle Hawking.
Okay, yeah, hurdle. Yeah. Where you just basically have a geometric feature of like a purely spatial part of the universe, and then that through some mechanism that I'm not really too familiar with, but it gives rise to like a space-time geometry, which is
Yep.
really cool. I didn't. Yep.
Yeah,
I
it
think
is.
that's awesome.
It's a very strange idea, but it's an interesting one.
Yeah. But I used to argue that if we assume that the universe did have an actual beginning and that there truly was nothing before it, I used to always argue then, like, okay, well, then there's no laws of causality, and that you can't assume that, like, oh, nothing can't produce anything, but because that like depends on causal laws. But if nothing exists, including causal laws, then I didn't see a reason to think that, like, okay, then the universe could have just literally popped into existence.
Yeah, I mean, like, that's the thing that I've heard before. The thing is when people talk about, so it depends on what you think of these like causal laws to be. Like, I take those causal laws to be like kind of descriptions of the way things are, and so like those causal laws, of course, they're not there if there's nothing, but that's not to say that they're not in effect, if that makes sense.
Okay.
So I wouldn't make that argument, but I can see why that like it just like it'd be like saying that like, oh, if there's nothing, then that means that logic is no longer valid. Like, I don't know if that makes sense.
Yeah, and like,
but I also
I'm
think
literally
that,
using logic to,
exactly. I also think that nothing is probably impossible regardless. Like, whether you're a theist or not, I think that you're gonna have a really hard time even coming up with a way that there could be nothing, right?
I know, yeah, it's like it's kind of paradoxical, or like it's kind of self-defeating almost by nature.
Yeah, like I don't have a proof that nothing can't exist, but I mean I've read a proof that somebody tried to write. I'm not sure how convincing it is, but like definitely it seems like there's a lot of like metaphysical tension in it being possible that there was at some state of affairs that there was nothing. That it seems like there's some issues there. It doesn't, of course, rule it out, but there's at least some issues.
Yeah, and it was just an argument that like I used to kind of just intuit, like it just kind of.
Yeah, and I get that.
Do I have time for one more question?
All right, go ahead.
Oh, okay.
No, that's fine. Go ahead.
Yeah. So like I think I've asked this about briefly before in the chat, but are you familiar with Langland's program?
Yes. Well, okay. I'm not familiar with it. I've heard of it. I know that it's a very, very deep and complicated area of mathematics.
Right, and you are like far above in the math field than me. Like I kind of just barely scratched calculus. I actually like started getting back into math though because of you.
Nice.
Partly.
Good.
Man,
More people need to study math just for fun.
Yeah.
It's good. It's good for your brain.
And I used AI to like give me like a lesson plan on.
That's actually.
I just wanted it to see if like
it's actually a really good use.
Yeah.
I would say like if you have the opportunity, and this probably doesn't apply to you because you sound like you're an adult who has like obligations. But like if you have the opportunity to go to university and you can learn from experts, that's a great way. That's a great way to do it. It's almost certainly better than using AI. However, if you're just like somebody who wants to like, start teaching themselves math again after 20 years working in industry or whatever, just out of interest, using AI for that, it's a great use of it. I mean, there's other resources that you can use, like MIT OpenCourseWare. There's various YouTube channels that will go over various courses. There's some open source books. There's Khan Academy. But AI is also like a good thing to put in your toolbox.
Well, it definitely gave me like a really good intuitive understanding of a derivative. Like it basically you could use algebra and then it kind of like, all right, if we have this f of x and then f of x plus h, and then you can actually just like literally intuit the derivative from the algebra. So it actually was pretty
just
cool.
One recommendation, by the way, and I know you have another question. One recommendation: when you do that, make sure that you open a book. Open a book and try like a textbook. There's some open source ones. Make sure that you can solve the problems to make sure that you're actually learning it, because it's very easy. One thing that I found that AI is really dangerous for is that it's very easy at convincing you that you learned something or that you're right about something or that you understand. It does a very, very good job of doing that. And so I could imagine that it's easy to convince you that you've learned this topic, but then when you go try to solve problems, you couldn't. So just use that as kind of as a backstop, if you will.
Okay, and like to go back, I was saying that like I was just mentioning Langland's program because all that I understand about it is that it basically links like areas of math with like harmonics that like
there's like harmonic analysis, there's like number theory, there's like algebraic geometry, there's like a lot of stuff that's going on.
Yeah, and then like somehow like you can basically translate a problem into like a harmonic problem, and then like you can get an answer, and then it seems to translate. And so I was just wondering if I assume the answer then is probably no, or you're just not aware. But I was going to ask, like, is there any application to that in physics then? Like,
I think that there is actually.
Okay.
I don't remember what it was, but I think that it has actually. People are trying to. I think so. I don't want to say definitely, but I feel like it does. Yeah.
Okay. Well, that's literally all my questions. So thank you very much for taking my call. I very much appreciate it.
Have one. Have one. Have fun. Take care.
Thank you. You too.
I meant to say have a good one, and then I also meant to say have fun, and then I did the wrong thing. Anyway, so I'm just gonna make sure that I didn't miss any extra questions while I was answering questions over voice. Okay, there's the beginning of these questions. I have a platinum meteorite. Cool. Almost all those disputes with Eternal Universe involve trying to jump back an infinite number of steps, then walk back a finite number of steps to today. You can't jump back through infinity. Yeah, that's exactly it. What do you think will happen if Super Kamiokande observes a significant proton decay tomorrow? There will be like 30 physics papers that appear on the archive the next day. Would we be quantum entangled with our copy? No. We'd be spatially disconnected from them, or causally disconnected from them. I wonder what is one good reason to drop atheism. I suspect it was a personal experience. That's what it is for most people who become theists, especially, or for people who become Christians in particular. And you know what? I can understand why personal experiences would be very compelling. Like, I can get that. Like, personal experiences are probably the most compelling things that we have access to. So like if he had a personal experience, then I can understand why he would believe it, even if it's not convincing to the rest of us. Can a wormhole open inside a black hole? It feels possible. It's a very complicated question. The answer is maybe, but the geometry would be very complicated. So many people say they were atheists but now religious. I used to be Christian, but now I'm an atheist. Pick a position already. I mean, yeah, like lots of people go through a phase as a teenager, which is why people, but they're generally not atheists in the same way that like Matt Dillahunty is an atheist, right? I only know of the fact that causal nihilism isn't incoherent and is a serious view in philosophy. That's all. Okay. No, I hate math. No, you should love math. Perhaps the good and bad thing about AI is that it will never tell you that your question was stupid. Well, a good teacher won't tell you that your question is stupid either. So, no, AI is terrible. Use your brain. AI is a tool. It can be used for good things. Like, look, one of the things that AI can be useful for is as a private tutor. Right? That's just the reality. Like, especially for elementary subjects like algebra, calculus, you know, that kind of stuff. It has, the LLMs have basically trained on the entire corpus of all human teaching on those subjects ever. And so if one method of teaching you something doesn't make sense, you can ask it for another explanation, and it will go find one of the millions of possible explanations and spit it out to you. A good tutor, that's what a good tutor does. A good tutor knows 100 different ways to explain something. And so if you're just like, if your alternative is just Googling stuff, it'll be more effective to have an LLM do it. Now, to be clear, you have to be careful with your prompting. You have to like, and you probably shouldn't use one of the models that hallucinates. That's really bad too. But you should also like, yeah, like Shay says, you know, tell your LLM to be critical of you every single time. Make sure that, and critical of itself every single time, that kind of thing. And, you know, then you can probably stave off the worst of the hallucinations. The other thing is that if you go back and you check your understanding by doing problems in actual textbooks, then you can check that to make sure that you haven't learned something incorrectly. So having a fail-safe, having a way to check is fine. This is not to say that like you should make friends with your AI when you're sad or lonely. Like you need human interaction. But a lot of the people who are saying like, no, you shouldn't use AI to learn things, like this is it's a very privileged position. Like the reality is that modern AI is actually like doesn't make mistakes all that often, especially if you pay $20 a month or something. It doesn't make mistakes all that often, and in fact, arguably, it probably makes mistakes less often than like any random post on the internet does. But the other thing is that not everybody has time to go hire a private tutor, or the money to hire a private tutor, or to go, you know, to go back to community college. A lot of people have to work and they have to take care of their kids, and so like, it's not the end of the world. What are fiber bundles and how are they used in physics? I've only heard of them. Fiber bundles are like basically, so the picture that I have in mind is you have a space, and then you just like imagine gluing strings to like each point in space. And now you have a fiber bundle. That's literally where the name comes from. You can assign a coordinate not just to the base space where you are, but you can also assign to each fiber like how far along the fiber you are. And so you can generalize that. So you're not just gluing a string to each point in space, or like a line to each point in space. You can also glue like spheres to each point in space. And so the point is that you can basically attach extra stuff to each point in space, and then you can twist it up, and the topology becomes a little bit more messy, and that's how you get a fiber bundle rather than a trivial bundle. But the point is that's the idea. You're like gluing spaces onto other spaces and then twisting them up so the topology is messy. From Git Stanfield with the $5, is there any current indication or direction of discovering a new paradigm in physics who were able to travel outside the solar system? Not that I've seen, no. All right, y'all, it is 10 minutes past the live stream ending, so I'm going to end the live stream here, and I'm going to go figure out some coffee, make some lunch, and I will see you guys tomorrow for more Ask a Physicist, although the members-only version will be slightly shortened tomorrow, because tomorrow I have a meeting at 11, I think, so I need to double-check that. So I will see you guys tomorrow. Take care, everybody.